Hello, hello, everyone. I hope you're having a good day so far. Happy Sunday. How's everybody's weekend been so far? Anybody do anything fun? Hey, Rascal. We'll get started in about 2 minutes. Hi, Renzi. Give folks a chance to get through the intro ads here. I don't know what the ad situation is like on. I don't know what the ad situation is like for you all on Twitch right now. I know it's been kind of weird for Leon. I have not opted into that new ad environment, that new scheduled ad thing that Twitch is trying to push. I have it's luckily it's still opt in, and I have not opted in. So I hope y'all aren't getting slammed with like 11 ads at certain intervals. 6 seconds. Oh, okay, that's great. That's perfect. I'm glad it was a short ad because yeah, I think it seems like that scheduled ad thing is just an excuse for Twitch to show you more ads. So I have not signed up for any of those incentives. Trying to keep it, as ad free as possible for you guys. Hey, Ty. Hey, Luis. Hey, Chris. I know for some folks that are not subscribers, they'll probably get some pre roll. So, 15 seconds? Okay, that's awesome. Yeah, that's super short. Good. I'm glad you're not getting like 11 ads. You've never been interrupted by an ad on Twitch? Wow. As long as you don't miss anything in 15 seconds. Hey, Amy, Alyssa. Hey, happy Sunday. All right. Hi, folks. Let's go ahead and get started. We're going to jump right into it today. Um, Hello. I hope everyone is having a good day so far. Hey, Rohit, welcome. Welcome to the stream. What's up, indeed? Yeah. So today we are going to take just a basic introductory look at React. Um, because the assignment in our, in the follow along materials channel for Tuesday was to read the main concepts of the React documentation. So that's what we're going to do, except we're not just going to like sit down and read because that's boring. I'm not going to read to you. There's channels out there that'll do that, but that's not my kind of channel. So what we're going to do is we're going to go through the concepts together. Um, but we're also we're going to kind of take a pause in the middle and do a tutorial, which is actually also in the React documentation website here, which I did already, and I actually found it was really nice and helpful because what it does is it takes some of the the big words in the documentation, the big concepts, and it explains them in really very plain language. It doesn't use big words. It just shows you some code and it gives you a structure of code that's already written, and you just go through and make changes in a step-by-step fashion to kind of illustrate some of the concepts that the documentation talks about in those big words. So I found the tutorial very helpful. So what we're going to do today is we're going to talk through like the first couple sections in the document, in that chapter, in the documentation chapter that we're supposed to read. Then we're going to pause, go over to the tutorial, do the tutorial, and then come back to the documentation. So that's the plan. Oh, first time here, Rohit? That's awesome. Yeah. Well, I hope you enjoy it. And as always, all of my previous streams are recorded. They're available as VODs for 60 days on my Twitch channel. And then after that, they move to YouTube. So I have a ton of previous streams on YouTube. So exclamation point YouTube, if you want to link to my YouTube channel where I put all of my older streams. Yeah, and I'll paste the link to the docs here in the chat. Um, so this is where we're going to start. I'm going to drop it in there for you. And also, the link is also in the follow along materials channel on the 100 Devs Discord. So go to the follow along materials channel, and the link is there as well. Yeah. Okay. So I'm not seeing any other questions. So we're gonna jump right into it today. I've been out of town for the last couple days, so I'll admit I'm kind of tired, but we're gonna get it. We're gonna get through it. We're gonna ramp it up. We're gonna go. And streaming always gives me a little bit of energy, so I'm looking forward to that. And so yeah, we're gonna go through the first couple sections of the chapter. Then we're going to do that tutorial, and then we'll come back to the documentation. We'll see if we get through the entire chapter in the stream today. It just depends on how much energy I have, honestly. So we'll kind of play it by ear. We'll feel it out. And then if we don't get through the whole thing, I think that'll be fine. Obviously, we're going to cover it in class. And so I think we'll all survive. So we'll see. We'll see how it goes today. I think it's going to be good. I got your you coding with strangers. Hey, that's awesome. You got your buggy Tetris game to work finally in good dough. That's rad. Welcome to the stream. Good to see you. Coding with strangers, super fun streamer. Definitely check them out. Hey, Hertz. How much JavaScript should one know before starting with React? That's a great question. So the documentation, what we're going to talk about today, does assume that you have some familiarity. So there's actually a section in the documentation called knowledge level assumptions. And so since React is, I think it spells it out really nicely here. It says, since React is a JavaScript library, we'll assume you have a basic understanding of the language. You could try out this tutorial to see if you feel like you're ready. I would say that understanding this documentation is going to require that you at least know what variables are, what classes are, how to write a function, how to do if else type conditional operators, and having a basic knowledge of HTML tags and how kind of JavaScript works together with HTML. Yeah. So I mean, those are the things that I've seen just by reading through the documentation already. So classes, constructors, conditionals, functions, yeah, and also knowing like what objects are, and knowing the basics of like object notation, like dot notation and that kind of thing. So if you don't feel like you're ready, that's fine. You can always just catch the VOD later. You can take the tutorial that they recommend, and then catch the VOD later. That's up to you. Hey Zena, hey Ruby, hey Ubaldoes. Yeah, but as Mavi said, JavaScript, React is pretty much JavaScript, so you should have a good familiarity level. All right, so first of all, let's see, go back here. Oh, come on, where was I? There we go. Functional components, so hot right now. Yeah, and I mean, if you are familiar with React already, some of the stuff in this document, in this chapter, you might be like, but you should do it this way, or there's a better way to do that, or something like that. We're just going to follow the documentation today. We're going to follow whatever's in this chapter. I am new to React. Most of us are new to React, and the assignment was, to read this chapter. So we're gonna follow what's in the chapter, but we can always, tweak our approaches as we get more familiar. Right now, we're just going to focus on the fundamentals, do a little tutorial, get our feet wet a little bit, and then don't worry if this stuff doesn't click right away. We're going to obviously be covering it for the next several weeks in class. So this is just an introduction, just getting our feet wet. It's going to be all good. Yeah, right. As Leon likes to say, no code weenies, indeed. Hey, Roy, I'm glad I recognize the terms you said, which tells me that I know at least the basics. There you go. Yeah, I think you'll be fine. It's all good. Yep. Yeah, and as Jazzy said, there's trends change, right? Languages evolve really quickly. But a lot of the times corporations still use a lot of legacy code. I can speak from experience. I've experienced that. Corporations are very slow to change. If it ain't broke, don't fix it. Or if it ain't broke, or if it is broke, fix it exactly the way it was and don't try something new, because what was already there has worked for the last decades, right? So it's good to know how to do things, sometimes the older way, and the newer way. So usually we start with the older methods and then we upgrade ourselves to newer methods. This documentation does talk about ES6 syntax, which is nice, but it does seem that it does kind of look at things in an older sense sometimes. Yeah. Good to know how classes work for sure. Yep. So, okay, let's go ahead and get started. So, what is React? We're just going to start at the home page here. A JavaScript library for building user interfaces. So, by user interfaces, we mean what the user sees on the page in the app, and what they interact with directly. And it tells us that it's declarative, component based, and learn once, write anywhere. So, yeah, basically, we're just going to learn how to create interactive UIs, and design simple views for each state in your application. And here's the important part. Oh, Ian Douglas, thank you so much for the raid. Hey, thank you. Good to see you. Hey, hello. Today we're just doing a quick introduction to React. We're going to go through a little bit of the documentation and we're going to do a tutorial. Looks like Christ is Sleep is excited about React. I love to see it. Nice enthusiasm. Woot React. Yeah, we're just getting started. I'm not really familiar with React, so we're starting from the beginning here. All right, so here's the important part of what React does. React will efficiently update and render just the right components when your data changes. So right now, with what we've been doing when we've just been using things like EJS and server-side code, is that whenever we have a page and something change, we want something to change on that page, we either do a redirect or a refresh, right? The whole page reloads just to update, maybe let's say a list. Maybe let's say we add one list item, right? We refresh the entire page. And it always seems like there should be a better way, right? Why do we have to update the entire page if only one small section, if only one list item changes? Why? And so what React is going to help us do is just separate our page into individual, components, right? Individual sections or little uh, blocks, puzzle pieces, whatever you want to call them, and those can kind of update independently of each other and refresh themselves when something changes, leaving the rest of the page static. So that's a useful thing. And it also lets us create, building blocks, and reusable components that can be reused multiple times in the same app. So helps us make drier code. And yeah, it has a lot of advantages. Bobby says infomercial for React. There has to be a better way. Yeah. Yeah, that's what it sounds like. Yep. Like those old infomercials that you used to watch at, you'd be homesick from school at 3 p.m. watching talk shows and you'd see all the weird infomercials. Yeah, absolutely. Yeah, so we're going to build encapsulated components that manage their own state, then compose them to make complex user interfaces. Okay, so that's the gist of why we're looking at React, right? It's just going to help us bring our apps up to that next level, because we've done a lot of work on the back end in the last few weeks. We've learned a lot about the back end, how to make things better on the back end, and now finally we're going to learn how to make things better for the people using our apps. Okay, so this is the chapter that Leon asked us to read, and again, I will put the link here in chat for you. So there's the link again if you want to follow along. And again, for those of you who just joined us, we're going to read the first 3 sections or so, Hello World through Rendering Elements. Then we're going to take a little sidebar and do a little tutorial that's going to introduce some additional elements on top of that using very plain language. We're going to, build something ourselves. And then we'll come back to the documentation and go through the rest of it and review the big words in the documentation. But I think the tutorial is going to be really helpful for us. Oh, we got to hydrate. Okay. 1 second. We got to pull I have a cup of tea here, but I just got to get the tea bag out of it. There we go. All right. Thank you for the hydrate. Hey, Jim. Okay. So again, I'm not going to read this to you directly, but we are going to kind of like summarize the concepts of each section. So hello world. And they give us an example of a small React component. And let's take a look at this real quick here. We'll zoom in just a little bit more. There we go. So it's declaring a variable and creating a root element, getting an element by ID, and then rendering something inside of that. So what it's rendering is just an H1 that says hello world. And so let's take a quick look at this on CodePen. What I love about this is it gives you examples in CodePen, so we can open them up and we can inspect what is actually in the code. So let's just take a quick look at this in CodePen. So we can see what we have here is some basic HTML. And all they've done is they've set up a div and they've given it an ID value of root. And we know already that we can use JavaScript to target certain HTML elements with certain ID values directly, right? We can target them. If we give them an ID name, we can target that element directly and do stuff to it. And so what we're doing here is now we have some JavaScript, which is getting that element by ID, attaching something to do with React to it, and then rendering something inside of that div that says hello world. So essentially, this is just showing us how React can hook to that HTML element, kind of say, all right, I've got it from here, and then put something completely different in there. Which website did I start from? Yeah, the homework. So if you go to the follow along materials channel, there's a link directly to the React documentation. And so that's where we're starting from. And what I've clicked on here is there's links to CodePen directly inside of the documentation, which I think is really cool. I love the way that this documentation is put together in general, just because it gives you tons of examples and you can open them in CodePen and mess with them yourself. Yep. So we just looked at that in CodePen. And so that just shows us really quickly how we're essentially putting a very simple div in HTML and then everything else is being done in React. All right, so they just tell us how to read the guide. In this guide, we're going to examine the building blocks of React, elements and components. And we can create, and what this is going to allow us to do is create complex apps from small reusable pieces, like I mentioned before. Now they do tell us that this documentation is really for people who prefer learning concepts step by step. That's not what I prefer. I prefer learning by doing. And so we are going to do this practice tutorial here in just a little bit after we go through a couple of opening sections. We're going to do the way I like to learn, which is just throwing myself at it head first and seeing what happens. So we're going to do it my way. But then we are going to come back to the docs and read the rest of it just because that's the assignment. Is peeping the tic-tac-toe this morning? Yeah, I found it helped a lot. Yeah, so we're going to learn the most of React by reading the main concepts. And it does assume that you have basic knowledge of JavaScript. Most of us do here because we are in 100 devs. If you're curious about what 100 devs is, you can type !Leon in chat right now. 100 devs is a free training agency and learning code boot camp, which teaches you how to become a web developer starting from zero. And then get a job at the end of it. And it's completely free. It's taught on Twitch and Discord, so no charges at any time, just free community learning. All right, so let's get started. All right, so the first chapter here, the examples with the clock did not register well in my brain. Yeah, and some of the examples in this documentation are pretty obtuse. That's why we're going to do the tutorial first. That's going to help. What's my GitHub? Do ! GitHub Ninja. Do ! GitHub in chat, and that should link you to my GitHub. Throw self cry, do it all again. Yeah. Oh, we got a stretch too. Okay, there's a stretch for you. Oh, there we go. Okay. So this next section is introducing JSX. Now, JSX is something new. It's not something that we've seen before. Um, but if we look at the syntax, it's interesting because it looks like a combination of JavaScript and HTML, right? We're declaring a variable and then setting that equal to what looks like HTML tags. So it's like a weird like mismatch. I don't know. Yeah, mishmash. There we go. I can't speak. It's a weird mishmash, and there's a meme that somebody shared with me on Twitter. Mavi shared with me on Twitter, and I'll try to remember to share it at the break because I feel like it describes JSX pretty well. Um, and it says, yeah, this funny tag syntax is neither a string nor HTML, and it's called JSX, and it's a syntax extension to JavaScript. Now, here's the important distinction. JSX may remind you of a template language, but it comes with the full power of JavaScript. So it's literally JavaScript. I mean, it's based on JavaScript. And so unlike other templating languages, it can, it can do more, right? It can be more powerful for us. JavaScript extreme. Yeah. And JavaScript produces React elements. So why do we use it? Okay, so React embraces the fact that rendering logic is inherently coupled with other UI logic, how events are handled, how the state changes over time, and how data is prepared for display. So essentially what we're doing here is the advantage is instead of separating out our JavaScript and our HTML in separate files, um, we can separate them loosely in components, what's called components. Now, we don't have to understand what that is right now. Just know that it is still separating concerns. So we always say, separation of concerns is important and all that. But it's going to be expressed in a different way using React. And they even give us a little bit of a, like they say, if you're not yet comfortable putting HTML and JavaScript together, or I say HTML, it's not really HTML, but there is a link you can click if you're feeling anxious. You can there's a talk you can click on apparently to assuage some of your fears. I haven't watched it, but just FYI, I know some folks freak out at but we're not separating concerns. We're combining things together, but apparently it's all fine. Bro collab, yeah. And it's also important to note that React does not require you to use JSX, but we are familiar with like HTML tags by this point, right? We know what they look like. We know how to use them, so we might as well use something that looks familiar, which is kind of why we were using EJS before, right? It looks familiar. We know how it works, so might as well just use it. But again, it's kind of like a mask. It kind of hides what's really going on underneath the hood. All right, so embedding expressions. In the example below, we declare a variable called name and then use it inside JSX by wrapping it in curly braces. So we declare a variable, Josh Perez, and then we set up an element which contains that name inside of curly braces. Now, where have we seen that before, right? We've seen the curly brace syntax before. We used it in EJS and we used it in handlebars. So we've used it a couple times now. We've seen how we can include sort of dynamic elements inside of curly braces. And then when it renders into the DOM, it looks like it's always been there, right? You can't tell the difference between it and regular HTML. So again, kind of similar to what we've seen before. Yeah, kind of like a template literal to embed variables. Exactly. Yeah. Hey, I'm Cotton. Now it says you can put any valid JavaScript expression inside of the curly braces. So they give us some examples here. There's a calculation. We've got dot notation for an object, and we can even call a function. So any valid JavaScript expression, we can dump it inside the curly braces and it will work. And now they show us an example here of calling a JavaScript function inside of an H1 header. All right, so we've got a function here that returns a first name and a last name. And we set up an object that contains first name and last name as properties here. And then finally, we set up the H1, which contains hello and then calls the format name function. So it just puts the first name and last name together with a space between them and displays them in an H1 in the DOM. We're going for that classic example, let name John, let age equal 32. We can't change it, it's the law. Yeah, exactly. We gotta start with the classics, right? First name, last name, hello. Hello world indeed. And you can look at any of these on CodePen. We're not gonna look at all of them if they're fairly self-explanatory what's happening. But I do think it's nice that you can literally open any of these in CodePen and see, how they render. I know I'm going a little bit fast here, but do let me know. Do stop me if you have any questions at some point, and I'll do my best to answer. But I feel like this is kind of similar to things we've seen before, right? We can declare an object. We can create a function which references that object, right? Using dot notation, returns the concatenation of the first name and last name as a string. And then all this is doing down here is it's just wrapping that string inside of an H1, calling the function and saying, all right, put the result of that inside of an H1 header and display it in the DOM. Easy peasy. And just a formatting note here, we split JSX over multiple lines. While it isn't required, they recommend wrapping it in parentheses to avoid automatic semicolon insertion. I don't feel like that's something we've had a problem with necessarily in JavaScript so far, but we can, keep that under advisement. And JSX is an expression too. So JSX compiles and then becomes regular JavaScript function calls. So if you can use JSX inside of if statements and for loops, assign it to variables, accept it at arguments, and return it from functions. So they give us an example here of that. Thanks, Scotty. Welcome to the stream. No worries. This helps me too. They say the best way to learn is to teach, right? And so the more I go over this, I went over it first solo myself. I did the tutorial myself, and now I'm talking through it again here on stream. And it's going to be just as helpful for me as it is for you. All right. So here we have a function, and we can use if else here. Well, I guess not just an if. We can just have an if statement that returns the user's name formatted with as hello whatever if the user exists, right? So if the user is present, then we can return an H1 containing hello user. Else, or otherwise, we can return hello stranger. So what all this is telling us is that we can wrap these tags, what looks like HTML tags, we can just dump them straight into functions and use them that way. And we can use quotes just like we can in regular HTML tags. And we can also use curly braces to embed a JavaScript expression in an attribute. Yeah, so here we have an image tag, and assuming that we have a URL stored inside of an object, we can just straight up embed that inside of an image tag, and it will render to the DOM just like a regular image tag would. So basically all they're showing us here is just how versatile this notation is, and how we can really substitute we can substitute essentially variables inside of HTML tags and have them render just fine inside the DOM. It says, it just reminds us, don't put quotes around curly braces when embedding a JavaScript expression in an attribute. You should either use quotes for string values or curly braces for expressions, but not both in the same attribute. Okay. Yeah, those statements without the else are confusing at first, right? Yeah. And just a naming convention, React is closer to JavaScript than HTML, which is also a good thing to remember. Again, it may look like HTML here using HTML tags, but it's not. It's closer to JavaScript than anything else. It's just masquerading as HTML tags. So in that case, we use camel case naming conventions for variables. And just like with HTML, if you have no closing tag, so if it's just a single tag like image, um, you can close it immediately with a slash close caret. And we can nest tags just like we can with HTML, right? We're used to doing nested divs, nested sections, that kind of thing in HTML, and you can do the exact same thing in JSX. Do I have an estimated length for today's stream? No, I do not, I'm afraid. I hardly ever do. In this case, definitely not. I have no idea how long it's going to take us to get through these docs. Yeah, I would say, so Xena, is it more similar to, what was the question? Make sure you see that. Is it more similar to EJS? Yeah, I do think EJS is a little bit more straightforward than this, because just JSX can just do more. JSX can do a lot. And whereas EJS is more like just, you can use, you can do basic JavaScript such as loops and that kind of thing as a templating language. Whereas I think EJS is, JSX is more powerful. But, again, just getting started with both, right? And it tells us how we can prevent injection attacks, um, because React DOM escapes values embedded before rendering them. So we've talked a little bit before about things like SQL injection, where if you have a form or something like that, and you don't properly sanitize or protect your inputs, somebody could potentially say pass a SQL statement, a malicious SQL statement saying, "Give me all of your user data." Um, like select star from users, where user equals active, pass that into your app, the SQL statement could potentially run and then deliver back a list of all your usernames. And that's surprisingly common. It sounds weird, but things like SQL injection are something that malicious actors do commonly use in order to try to hijack apps and get data that they're not allowed to have. And so they say, JSX prevents that. So good deal. SQL is really powerful. Yep. SQL has a fairly narrow focus, but it does what it does really well. My eyes go on strike after staring at too much EJS notation. Yeah, so JSX is nice because it looks like what we're familiar with, right? At this point, we're very familiar with JavaScript and we're very familiar with HTML. And so this looks like a very clean mixture of both. And basically here at the end, what it's telling us is that Babel compiles JSX down to what it actually is, which is a create element call. So this may look like HTML tags, right? It may look like H1 and H1, and you would think, oh, that's just going to compile straight to an H1 tag. But what it really is, underneath, it's like Scooby Doo. They remove the mask off the villain at the end. What it actually is this under the hood. So this is what it compiles to. It looks a bit different, but you can just treat it like you would an HTML tag. So you don't have to worry about what this means or the difference between it. Just know that what you're writing here, when you're writing what looks like HTML tags in JSX, that's not exactly what it compiles to, but it's being nice to us. And it says it does perform a few checks to help you write bug-free code, but it just creates an object for you. And these objects are called React elements, and you can think of them as descriptions of what you want to see on the screen. React reads these objects and uses them to construct the DOM and keep it up to date. Okay, so what does it mean when we render these elements? Well, that's in the next section. Oh, thank you for continuing your gift sub, Mama Han. Thank you. I appreciate it. Okay, so what is an element? Well, elements are the smallest building blocks of React apps. And basically just the element describes what you want to see on the screen. And in this case, the smallest, a small element like this would just be H1 tags with some text inside of them. And we saw earlier what that actually renders to is a React.create element, and then it describes exactly what those components are, and then renders those elements in the DOM. Unlike browser DOM elements, React elements are just objects. And we saw that before, so I'm going to skip back real quick. So it's just an object, right? It might look like HTML tags, but it is literally an object with various properties. So that's all it is. Very simple. It's just masquerading as HTML tags. And it says, you might confuse elements with components. Components are something different. They'll be introduced a little bit later. So elements are what components are made of. And we encourage you to read this section before jumping ahead. Okay. So how does an element get rendered in the DOM? Let's say there's a div somewhere in the file. And we saw this earlier when we looked at the basic hello world code in CodePen, right? We have an HTML file. So this is true HTML right here. Like, this is not a React thing. This is true HTML. We have an HTML file, and we have a div with an ID of root. And we saw that when we looked at the CodePen code earlier. Div ID of root. And then what our React does is it hooks into that file to do what it needs to do and render in the DOM. So we have a div with an ID of root, and everything inside of that div will be managed by React. So all we need is this shell, and then we just need the taco shell, and then React is going to add all the ingredients to the taco. Applications built with just React usually just have a single root DOM node for the React to hook itself to. And if you're integrating it, you might have more root DOMs, but we're just going to act like we're just going to approach it from the perspective of a pure React app with a single root DOM node. So if we want to render inside of that single div that we just created in our HTML file, we just pass something called React DOM create root, and then pass the React element to render. And that's what we saw before, right? So we just got that HTML element by ID, which we've done before. That's what we've done that a ton, right? In most of our apps, at some point, we're getting an element by ID and we're doing stuff to it. And that's all that React is doing. It's grabbing that root div and it's dumping, it's creating some what it wants to render. So in this case, an h1 tag with hello world in it. And then it's just rendering that element. So fairly simple. And what that does is just displays hello world on the page. So really the only purpose of the HTML file here is just to provide a hook, a place for React to put that output. Alternatively, could it just as well be an HTML tag to render instead of targeting a div with an ID? Well, from what little I know, you do always need some kind of a root hook inside of the HTML file itself. So you need some kind of a hook inside of the HTML file, and then React can handle everything else as long as it has something to join to. Yeah. I could be wrong. Like I say, I'm literally at level 1 on this stuff. But from what I've seen so far, you got to have some kind of a hook, and then everything else can be handled inside of React. Okay, so we render something once, right? But the whole point of React is that's not what we want to do. The whole point of React is that we want to have these individual components that can refresh themselves or change themselves based on what's going on the page, right? We want things to be more flexible. We don't have to keep reloading, redirecting, refreshing the entire page every time that something changes. So if we want to update the rendered element, we have to do it in a slightly different way. So React elements are immutable. Now that's a fun vocab word. Once you create an element, you can't change its children or attributes. An element is like a single frame in a movie. It represents the UI at a certain point in time. So in order to get around that so far is we can create a new element and then just pass it again to the render command. So render it again. So that's what this clock is doing. Again, it's hooking to our root div. We have a function called tick, and we're creating an H1 that says hello world, and then we're adding an H2 that creates a date and then renders that date. That's a date time, I guess. Create a date time and then render that. But the crux here is that it's also creating a set interval, sorry. So every second, it's going to call tick again. So it's essentially, it's just calling tick once per second over and over and over again and re-rendering that individual element. So to be clear here, it's not reloading the whole page or refreshing the whole page. It's just calling this single element again. So tick, 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 tick. So let's see how that looks. And we can see the clock is ticking. Now, I don't know if you've ever used CodePen before, but with CodePen, every time you make a change, it there's a big pause and it refreshes the page and all that. We can see that's not happening here. It's literally just calling the function over and over again once a second and ticking the clock by 1. So fairly simple, pretty cool. But what's important to know about this is that React only updates what's necessary. So here they take a look at the back end here. So we can see this if we want to. We can inspect this. We're going to inspect that last example using our browser tool. So is it refreshing both the H1 and the H2 in the div? No, that's the cool thing. It's not. And that's what they're showing us here. So they show us hello world and the clock. But in the H1, you can see that the hello world is remaining static. It's not updating. Your, your answer got answered, yes. What we can see flashing here in the developer tools is just the clock. So the clock is the whole page isn't refreshing, right? Just the clock is the only thing that's updating. And so it tells us here, even though we create an element describing the whole UI tree on every tick, right? This function is describing the div, the H1, and the H2, and we're calling it over and over and over and over and over and over again, right? So you would expect, with the way we've done things so far, that if I was calling this over and over again, everything from the div on down would just keep refreshing, and we would see this whole thing flashing and refreshing. But the way it works is that it's really only it's seeing the thing that updates. In this case, it's just the clock. And that's the only thing it's changing. Yeah, so the only thing that's updating is the clock, and we can prove that. So let me make sure I'm on the right page here. Yep. All right. So I'm going to open DevTools here. I'm going to open debug mode in CodePen. And we can see that opens it up here. And then I'm going to inspect this. And we should be able to see. Let's see. Should be able to see. There we go. Yeah. So notice how the clock is the only thing flashing. The clock is the only thing updating. The rest of this is staying static, just the clock. Yeah, so pretty neat, huh? That's different than what we've seen so far when we've built our apps. Normally we would expect to see that this whole thing, every time we call the function again, we would expect that this whole thing would update and it would be very chaotic in here. But instead the clock is the only thing that flashes. Yeah, React is a cheapo and doesn't like to waste resources refreshing the entire page. And that's what makes it cool, because as we add more features to our apps and as we build more more complicated things, right, resources are going to become important to us. We add more multimedia, we add videos, we add interactive tools, we add animations. We're going to need to start being careful about how many resources we use when we make changes to a page. So that's why this is important. Okay, so yeah, we essentially just proved what they said there. Um, and in our experience, thinking about how the UI should look at any given moment rather than how to change it over time eliminates a whole class of bugs. Okay, so we're gonna do, let's see, do I wanna do this section? No, I think we're gonna pause here on the documentation and we're gonna do a tutorial, a very short, tutorial, which I feel like illustrates some concepts really well. We're going to do a tutorial and then we're going to come back and keep going through the documentation because things start getting a little dense after this section. And I feel like the tutorial is a good soft introduction to a lot of these things. Just kind of getting your hands on it first. And then we'll go into the deep explanations in the documentation. Instead of a clock, could you have a simple counter, count by one every second? Well, yeah, whatever you wanted to do. The concepts are the same, right? The only reason we're using a clock here is just because it's easy to implement. But really, whatever you want to render, and we're going to see an example of this, whatever you want to render, you can, once you know the basic building blocks of React. Hey, piece of shoot. Hey, Sun Pits, if you want to catch up on YouTube instead of watching the stream live, that's totally fine. You can do exclamation point YouTube in chat and you'll find all of my old streams there. You can also find all of my VODs from the past 60 days here on my Twitch channel. So if your internet is very slow, I know a lot of folks have slow internet. And so if you prefer to watch things on VOD, on video, you can do exclamation point YouTube or just check out my Twitch channel for my more recent VODs. When we get to props, I have a Queen song. Okay. Well, let's check out this tutorial, which is also in the React docs themselves. So we're not going anywhere else. We're not going to, Code Academy or anything like that. We're staying right here on the React docs, and they have a nice interactive tutorial that we can do to help introduce some of these concepts. So we have the very basics, right? We know why React can be useful to us. We've seen how it hooks to HTML to kind of dump stuff into the DOM. We've seen what JSX is and how it looks similar to HTML, but it really isn't. It's just sort of a mashup of JavaScript and HTML concepts, right? So let's go to the tutorial. I'm going to close some of these other ones here. I'll link to the tutorial. And I'll drop a link here in the chat so you can go there as well. The link is also at the start of the documentation that we were just looking at, so you could also click that. So what we're doing is we're going to build a small game, and we're going to be building Tic-tac-toe, which a lot of us have built before in JavaScript, except we're going to be building a React version of Tic-tac-toe, and it's pretty cool how it works. It's going to do things like automatically determining the winner, automatically alternating between X and O, automatically keeping track of all previous terms, or turns. So it's going to give us a turn-by-turn description, kind of like a lot of chess apps do. So it's going to have a lot of really cool features in a fairly simple amount of code. Pizza, code along or just watch. You don't need to install anything. That's the cool part. We're going to do everything in CodePen. I have not installed anything in VS Code. Everything can be done in the browser. And so that's where we're going to start for now. We might install some things later, once we get into React a little bit more, but you do not have to install anything. There are no prerequisites. I'll drop the link one more time for you here. There you go. All right, so you might be tempted to skip this tutorial because you're not building games, but give it a chance, they say. The techniques you learn in this tutorial are fundamental to building any React app, and mastering it will give you a deep understanding of React. I don't know about deep, but at least a good understanding of the basic concepts. And this tutorial is designed for people who learn by doing, which is me. It also gives you a link back to the step-by-step guide if you prefer that. So we're going to get a setup, we're going to get an overview, completing the game, and adding time travel to the game. Oh, we got a hydrate there. Okay. Yeah. And Rascal says you can do a fair amount of intro to React without installing anything. They even provide a single page HTML if you want to run locally but not install anything. Yeah, we're not going to run locally today, but you can if you want to. We're going to do everything in CodePen, just so it's easier for me to not have to juggle a bunch of windows. But we're going to do everything in CodePen, and I would say that's probably the most straightforward way to do it. Oh, thank you, Soundpits. Okay, so what are we building? We're going to build an interactive tic-tac-toe game, as I mentioned already. And we're going to take a look at the final result here in a second. So I'm going to open that in another tab. And we recommend that you check out the tic-tac-toe game before continuing with the tutorial. So yeah, we're going to take, just like I normally do with my tutorials that I do here on stream, or my projects that I build here on stream, I always show you guys the finished project first so that you can see what we're shooting for, right? You can see all the features, you can see what some of the concepts are, kind of what we're aiming for. So you have the end result in your head before we start building. So that's what we're going to do today in just a minute. One of the features that you'll notice is that there's a numbered list, gives you a history of all moves. Yep, we'll take a look at that. So prerequisites. We'll assume that you have familiarity with HTML and JavaScript, but you should be able to follow along even if you're coming from a different programming language. We'll also assume that you're familiar with programming concepts like functions, objects, arrays, and classes. So that's kind of what we talked about before, right? And we're going to be using some ES6 features, including arrow functions, classes, let, and const, which we've all used, so perfectly fine. And they give you a couple setup options. So we're going to do with option 1, which is writing the code in the browser. Or you could also open it in your dev environment like VS Code, up to you. We're going to do step 1 though, or option 1. Okay, so before we go to the overview, let's go ahead and take a look at the finished project and see what we're building today. All right, I'm going to change a couple things here. I'm going to move this to a new tab. Come on. And I'm going to increase the size of the grid here and the size of the fonts. So give me just a moment to do that. So I'm just going to change the CSS and make this, let's see, 20. We'll try 24. There we go. That's good. And then I'm also going to make the grid a little bit bigger as well. 60 and 60. And change the font size to 36. Okay. All right, so let's take a look at some of the features of the finished project here. So basic tic-tac-toe, I click, and the first thing it puts in is an X, right? Now we can see that a couple things have changed when I did that. The next player value was changed to O, and it's also keeping track of my moves. So it created a new button, a new list item, and a new button, right? Now it says go to move number 1 or go to game start. So let's keep going a little bit. I'm going to add another one. So it put an O this time. I didn't type that. I just clicked. I clicked in the grid. It added an O, and now it's tracked an additional move. All right, so I'm gonna put an X now. X, O, X, O, X, O, and I'm gonna let X win here. X. Okay, so now X has won, and we can see that the text updated to say winner is X. and it's kept track of every single one of my moves. So let's see what happens if I click on a previous move. I'm going to click on move number 4. Check that out. So it's rewound time. It's wound back the clock. It's wound back the clock to move number 4. Now, what do we think will happen if I decide I want to play a different move? So in a different order. Honestly, I don't remember which square I clicked next in the original version. So what do we think would happen if I click the bottom right corner here and lay an X? I was rooting for X. Erase the future. So by that you mean create a new branch, maybe clear the existing moves and kind of start things fresh from move number 4. Is that what you're wondering? Is that what you're thinking might happen? Fight the future. Yeah. Okay, let's see if that's right. Let's click. Yeah, look at that. So it erased the previous history, but not what had already been. So we went back to move number 4. It erased everything from move 4 onward because I chose a different square. Now it's creating a new branch. It didn't erase the things before move number 4, just what came afterward. So what that tells us is it's smart enough to keep track of the entire history of all the moves, rewind back to that history at any point, and then create a new record of that history depending on when we branch off. When mine sheep. Thus proving the multiverse in regards with time travel. Yeah, it's exactly, that's honestly how I think of it. It's like we're rewinding history and we're creating a new branch, a la the Avengers movies where they talk about branching realities and all that. Yeah, it's essentially we're creating the multiverse here. And so again, we can do that. We can even go back to the start of the game. We can clear the board um, and start over. Clear the history. Oh, that's interesting. Oh, okay, that's interesting. So it didn't. It made me stop clicking because X won. Right, I wasn't able to fill in the rest of the board because X won the game. So it stopped me from clicking. Went AFK for 5 seconds and we went from React to the multiverse. Gotta love learning the code. Yeah, exactly. The possibilities are infinite. Yep. Yeah, and so I think this is pretty clear what this is doing. But what's interesting about it is it's not anything particularly groundbreaking, right? It's we've done things like this before. But what's interesting is that we're not reloading the whole page every single time. We're only changing the components that need to change when we need them to change. All of these are encapsulated, and so nothing changes until it needs to. And we're also able to keep track of the history or the state of the object at individual times. Yours doesn't change when you click on it. It should in CodePen. You shouldn't really have a problem with it not running. Um, yeah, I'm not sure what's going on there. Might try refreshing and opening it again, and then and trying it again. See if you can get it to run. Just feels like the Doctor Strange Dormammu battle. Yeah, a little bit. Okay, so I think that's enough setup. We kind of know how it works now, right? And so let's get in to see if we can build it. So a quick overview of what is React. Some of this is going to be review, but we literally just talked about it, so let's talk about it again. And maybe in slightly plainer language, which is what I like about this tutorial. So let's get an overview of React. React is declarative, efficient, and flexible JavaScript for building user interfaces. Okay. And it lets you compose complex UIs from small and isolated pieces of code called components. That's the advantage of it. React has a few different kinds of components, but we'll start with React component subclasses. Okay. So here they show us a shopping list, and It's creating a class called shopping list and rendering a div containing an h1 and a list of items. However, we can see that there is a variable component here called this.props.name. So we don't quite know what that is yet and what props are, but clearly there's something in here that could be a variable item of some kind. So we'll get to the funny XML-like tags soon. We use components to tell React what we want to see on the screen. When our data changes, React will efficiently update and re-render our components. So this component takes in parameters called props. So that's a word we're going to see a lot. So, we kind of know already like what parameters and arguments are, right? Those are the things that get passed into functions to give them input, to tell them, what's going into them, and then something that's what the function uses to accomplish its task, right? And so props are kind of similar to that. Props are properties that get passed into the component and then something happens. And this render method that we see here then returns a description of what you want to see on the screen. React takes the description and displays the result. So render returns a React element, which is a lightweight description of what to render. So we talked earlier about how JSX kind of looks like HTML tags. But what's really happening under the hood is just React creating a simple object of some kind, and that's what's actually doing the work. So what we see looking like HTML tags, looking like ULs and LIs, it's just window dressing. It's just cosmetic. Something else is happening under the hood. So most React developers use JSX, which makes these structures easier to write. So the div syntax is transformed at build time to react.createElement div, which we already saw, right? We saw that's what they told us already. The div is just cosmetic. It becomes something different at render time. So this big example here, what that looks like HTML that we're used to, div, h1, ul, li, that renders to something like this, a bunch of React create element statements. So JSX has the full power of JavaScript, and you can put any JavaScript expression inside of JSX. Yep. Each React element is a JavaScript object that you can store in a variable or pass around in your program. So the shopping list component only renders built-in DOM components like div and li. So we already know what those are. Those are tags we're familiar with. However, with React, we can make our own tags. So we can compose and render custom components. So we could essentially encapsulate this entire component here, this whole thing, inside of a new tag called shopping list. Now that's not a built-in HTML tag, but with React, we can essentially turn it into a tag and render it that way. Each React component is encapsulated and can operate independently. So we can build complex UI. So imagine having a bunch of custom tags like this. So let's say maybe header, and then search bar, user login, main body, news stories, comments, and just dropping each of those custom tags into your page one by one. And then you click, and then you save it, and then in the browser, all these components bloom out into a fully rendered page, which is pretty wild. So this is just a little taste of the power that we are starting to dip our toes into, right? Would you use React for website building, or would that be overkill? Yeah, you wouldn't necessarily use this for a static website, right? That you can still build static websites. This is not saying that it's better than HTML. It's just saying that if you want to have modular components that can operate independently of each other and update a bunch of different things on your site independently of each other, then React could be a great solution for that. So does React replace the index.html, or would it just be a div to hook onto? Could you use a custom template for HTML and CSS, but then implement React for something more complex on the site? Yeah. So I believe that you can. There was a reference to that a little bit earlier in the documentation, talking about how you can have multiple. If you have an app that you want to just add React to, so put React on top of it, you can have multiple root elements that you hook to inside of that app and add React, components inside of that. So yeah, you can modify an existing app that didn't previously have React and add React to it. You can feel the power. Yeah. And dynamic on top of that. You gotta love it. Yeah. So this is really powerful, right? It's clicking. Yeah, yeah, yeah. And and like with anything, right? It's not necessarily that anything is better than anything else. There's always going to be a right tool for the job at the right time, right? What's important is that we expose ourselves to a wide variety of tools, and so that we know when we see a use case that's going to be good for us, you'd be like, oh, I should use React here, or no, I can probably just use EJS and that'll be fine. Or I don't know, maybe for a static site, maybe I don't need any of those. Maybe I'll just want to drop some HTML tags in there and call it a day. And so it's really about where you just knowing as much as possible about these different solutions, so that you can know, have a whole Swiss Army knife and know what's the best tool for the job, right? Yeah. Okay, so if we're going to work on the tutorial in a browser, you open this code in a new tab. So we're going to open our starter code. This is the code we're actually going to be building on top of. So I'm going to open the code, and I'm going to drag it over here to my other window. And real quick, I'm going to again update the CSS. I'm just going to copy it from this other one here and drop it in, just so you all can see more easily. There we go. Just made things a little bigger. Now we can see when we compare these two, there's some features that are missing, right? Obviously. we're missing the list of previous moves. If I click in the squares, nothing happens. So clearly some features are missing, and we're going to need to expand on this code in order to get it to work. So inspecting the starter code. And I'll paste a link to this in the browser as well, so you all can open this as well if you want to. There you go. Now, this is not going to work. So you click on this, nothing's going to happen. So don't worry if this one isn't working. Don't worry, it's not supposed to. And you could always work on this locally if you would like to, but we're going to use CodePen because it's easier. All right, so this starter code is the base of what we're building. We've provided the CSS styling, so we're not going to touch the CSS. We're not going to touch the HTML. We're just going to be working in the JavaScript file here. So let's take a quick look at the code. It's fairly short at the moment. There's not a ton here. We have something called Square. We have a class called Square. Oh, MME says, oh, I opened the starter code earlier. That's why the clicking didn't work. Yeah, Chanpo, I was wondering, I was maybe thinking that, but I wasn't entirely sure. So yeah, if you open the starter code earlier, yeah, it wouldn't work because it's not supposed to yet. But that's totally fine. Now you have it open, so you're ahead of the game. No worries. And that's the last time they ever touched raw HTML. We'll see. I don't know. Right tool for the job, right? Okay, so we have a few classes here, right? We have a class called Square. We have a class called Board, which is doing a lot of things. If we just kind of scan through this, we can see it says, all right, class board, it's doing something called render square and render next player X. Okay. And then return a bunch of divs calling render square multiple times. And so what it looks like it's doing is it's calling render square one time for each square in the grid, right? And so what is render square doing? Well, render square is returning this custom tag called square. Okay. So return square. Well, we have this class up here called square. So essentially it's just calling this class 9 times. Okay. And each time it does that, it's creating a button called square that we can click on, or we will be able to click on once it's ready. So all that's doing is it's just saying, all right, here's our board. This is our board. Render 9 buttons inside of it that contain clickable squares. Okay. And then we have another class down here called game. And that's saying, all right, you're going to render something, render a div called game, render a board, and call that custom board tag that we saw before. So call board, which then calls class 9 times. And then we're going to have some game info, which we haven't filled out yet. Okay, so we can kind of see some relationships going on here, right? We have something called game, which renders a couple divs, and then hands it off to our board, which creates a board, and then hands it off to the squares 9 times, which then renders the individual squares. So there's a relationship, right? We can see that there's a relationship between these different classes. So React components are just classes. Everything's an object. Yeah, remember what Leon said is true. Everything is an object. Yep. In the end, that's what it boils down to. With JavaScript, everything's an object. Yep. So there's definitely there's a relationship here, and we're gonna explore that relationship as we go through this and build out the tutorial. Okay, and so finally, so it's an object all along. And finally, we have our root. Now remember, the root is what actually hooks React to the HTML itself. So we've seen this before, React DOM, create root, get that root div just to give the React something to attach itself to, and render the game inside the div. So it's easy to imagine if you had a web page, let's say we wanted to put tic-tac-toe inside of our existing app, right? Let's say we had our app all built up and we just wanted to put a little tic-tac-toe game in there. All we would really need to do is just insert that root div, give a React something to hook to, and then it could insert itself inside of that root div. So we can kind of see how this could be useful, right? It doesn't really come in handy here because this is all that's on the page, but I can already see how you could just sort of insert React into your existing apps and make it play nice with what you already have. Okay, so I think it's about time for a break. Amazingly, time seems to be flying today, but let's go ahead and take a break. And when we get back, we're going to actually start modifying this code to do stuff. So the first thing we're going to do is make the code do something right now, right? Because right now it doesn't do anything, right? We've got missing, our buttons don't do anything. There's nothing in here. We can see these relationships, but they haven't been established yet. So the next thing we're going to do is we're going to learn how to pass data to and from, actually downward through these relationships to make stuff happen on the game board itself. But it is time for a break. If you're new here, we like to take breaks once every hour or so, just 5 minutes, so you can get up and take a stretch, use the restroom, get something to drink, whatever you need to do. So that's what we're going to do now. All right, the Google timer is working today. Hooray! All right, so we're going to reset this, put 5 minutes on the clock, and I will see you back here in 5 minutes. And we're actually going to start doing some React coding. Hooray! I'm excited. Let's do it. All right, starting the timer now. And welcome, Calf. Total noob to React. So am I. I'm a total noob. So you came at a pretty good time. We're just starting a tutorial. If someone wants to share the link to the tutorial with Calf, they can definitely follow along because we are just getting started with it. And so it should be you should be able to jump in there. Thanks for sharing the links, folks. I'll see you back here in just a bit. All right, folks, come on back. We got about a minute left in the break, so pour yourself a fresh cup of tea or water or coffee or whatever, depending on the time of day, and come on back. Calf says, I've only used Java or C++ myself, but even then I'm fresh out of school with no real world experience yet. Hey, that's totally fine. A lot of the folks, in my streams were, just learning to code, getting started. I'm a SQL developer, but I don't really have any prior experience with JavaScript or web development tools prior to starting the course that a lot of us are in called 100 Devs. So a lot of us are noobs. It's all good. So you're in good company there, Calf. All right, I'm going to go ahead and stop the timer so it doesn't beep at us. And let's get back to it. Okay, so by inspecting our code, we'll notice that we have 3 React components, and we already kind of looked at those. I got to turn my camera back on. Sorry. There we go. The square component renders a single button, but the board renders 9 squares. And then the game renders the board with placeholder values that we'll modify later. Yeah, so we already looked at that relationship. We can see there's a cascading relationship between the 3 components. But there are currently no interactive components, so let's fix that. Passing data through props. Okay, so we touched on props a little bit before. So remember that props or properties are essentially similar to what we might see as like arguments in a function, right? We can take values or variables or whatever and pass them in, and then the function or whatever can use them, transform them, do things to them. They're just the inputs that we're taking in. So that's what props are. As we introduce these new terms, it's important to remember it's not something really new or revolutionary. It's just a different word. So props, arguments, similar. So to get our feet wet, let's try passing some data from our board component to our square component. And somebody asked earlier about coding along. So even the tutorial recommends, we strongly recommend typing code by hand as you're working through the tutorial and not using copy paste. This will help you develop muscle memory and a stronger understanding. So that's what we're going to be doing. I know I normally say copy paste, but with these brand new concepts, I think it's not a bad idea to just kind of type things out and see how they fit together. Okay, so we're going to try passing some data from our board component to our square component. So we have our board here, and we already know that it has a sort of a parent-child relationship to our square. So let's see how we can pass things into our square class. All right, so we're going to look at the render square method, and we're going to change the code to pass a prop called value to the square. Okay, so we already saw render square here. And all we need to do to pass a value into our square is just add a little bit to the tag. So value equals I. Okay. Square value equals I. Now we can see that the pen refreshed, the code pen refreshed, but nothing happened yet. Okay, so apparently we need a little bit more. Apparently it's not just that easy. But doesn't this look kind of familiar? Doesn't this look kind of similar to how we might pass an argument into a function? Right? You would say the function's name, and then you would just simply tell it what you want to pass in. That looks kind of familiar, doesn't it? It's written a little differently, but it's still recognizable. Now we just need to change the square to be listening for some information and take that in. So we're going to change the squares render method to show the value by replacing our to do with this.props.value. Oh, look at that. Look at that. So as soon as I did that, now it's showing the numbers 0 through 8 inside of each of the squares by magic. So let's take a look at what actually happened there. So each time we render a new square counting upward by I, so kind of like we would for an array of some kind, for each I square, we're also passing that value into the square itself. So we're saying, all right, square, you should be listening for something. I'm going to give you a value. And then square is like, yep, I'm going to return a button with a class name of square. And then the value of that button is just going to be whatever was passed to me. Magic. Yeah, exactly. Now we've seen the this keyword before, right? We've seen the this keyword before in reference to classes. And so if we recall this, the word this, the keyword this, basically just kind of refers to, in broad terms, it kind of refers to whatever the parent is, right? So basically just saying, hey, the parent of this, get the value of what's being passed in and use that value. Hey, muckety muck. Yeah, we're just using just basically just a little bit of CSS and experimenting with basic React. Yeah. And the tutorial that we're using is, I'm going to drop a link for you there, muckety. You can follow along if you want as well. We're just doing it in CodePen today for simplicity's sake. Okay. So fairly simple and not really any, oh my gosh, just another grads. Thank you so much for the gifted subs. Wow. Thank you so much. If you just received a gifted sub from Gratz, please do thank them. Maybe show off some of your new emotes that you now have access to. Yeah, very nice. Okay. So fairly simple and not really anything different than what we've seen so far, right? We already know that we can pass things from a function into another function, right? That's not unusual for us. And so that's really all we're doing here is we're just taking something from our board and we're passing it into the square using the this.props.value notation here. So and this is just showing us a before and after. So what you get should look just like this. And if you get stuck, if your code isn't looking the way you expect, make sure that the only values you have changed are explicitly the values that they specify here. They even, what's nice is they even highlight. So look for the highlights. Those are the values that are being changed. So these two values were what we changed. But if you do get stuck, if you get lost in the sauce, what I really love is that at the end of each step, they give you a link to view the code at that point. So if you get stuck and you can't figure it out, you can always just click the link and go straight to the code as it is at that point in the tutorial. Yeah, and so make sure that you're using I instead of one. So this is, I don't know if you can see that, maybe it's a little hard to see, but that is an I value instead of a one value. Hey, blah, welcome. Good to see you here. We're just doing a little tutorial because I found that the React documentation is pretty dense and it uses a lot of big words. And so they also have this really great tutorial that uses a lot of small words, which are a lot easier to understand. So that's what we're doing today. And we're going to go back to the documentation, but we're making a little interlude here to practice some concepts. Disrespect, yeah. So yeah, that if you get stuck, if you can't figure it out, you can always click the links at the end of each step to see, to essentially correct any issues that you might have. React somehow manages to have awesome docs and overwhelming docs at the same time. Yeah, which is, this tutorial is much easier to digest. Hey, great troubleshooting, FEO. All right, so this is all well and good, but this is not tic-tac-toe, right? The point here is to make a tic-tac-toe game. Now, right now, we just have the numbers 0 through 8. So let's make this actually be interactive. So instead, we're going to fill our square component with an X when we click it. So on click, we want an X to fill the square. Now remember, each of these are actually buttons. So luckily they already kind of have, some functionality that will allow us to click them and do things, make things happen on a click. So that's what we're going to do here. So first we're going to change our button tag. and we're going to tell it what to do when it's clicked. So inside of our square class, instead of just rendering whatever gets passed in, that 0 through 8 value, we're actually going to have it do something on click. So inside, let's see, inside of our button, inside of the opening tag, so be careful where you put this. It needs to be inside of the opening tag for button, say on click, and then inside of there, we're going to have a little function. You're going to get some errors as we go. It's okay. On click, make a function, and we're going to start just by console logging the word click. So console log click, if I can spell. All right. So let's see what happens. If we click on a square now, we should see the word click in our dev tools. Now in CodePen, you can open the console by just clicking on the word console down here in the corner. So let's see. All right, I'm going to click and clear the console first, and I'm going to click. Hey, look at that. Click. Click. Each time I click, a new word click is being rendered. Cool. So that shows me that the click function is working. That warning. Yeah, you're gonna get some very scary warnings as we do this. It's okay. Just keep going, power through. But yeah, you're gonna get some very scary red warnings in CodePen while you're typing. You could always turn off automatic updates if you really want to, but I'm gonna leave them on because we're baddies writing bad code. It's all good. It does give you some pretty detailed warnings though, which is really nice. All right, so we're able to console logs. And so what that's telling us is that this on click is working properly. And so now we can actually have it do what we want. I'm going to close the console for now. And it says to save typing and avoid the confusing behavior of the this keyword, we're going to use arrow function syntax for event handlers because the word this is confusing. I think we can all agree. And inside of the onClick, we're passing a function as the onClick property. React will only call this function after a click. Now, if you forget the parentheses and the arrow and say onClick console log click, it will fire every time the component re-renders. And I think we've all done that with event listeners at some point. Forgetting, when you're trying to call a function inside of an event listener, and if you forget the parentheses, it'll just call itself as soon as you reload the page. So I think that's something we've all done at some point. We haven't really used onClick before, but I think it's fairly self-explanatory what it does, right? OnClick, do a thing. All right, so as a next step, we want our square component to remember that it got clicked and fill it with an X mark. To remember things, components use something called state. So state is really important in React. And we're not going to get too deep into it in this tutorial, like as far as the implications, but it is going to come up in the documentation. So for now, we can just kind of remember it as like the current configuration of whatever element we're looking at. So something is clicked. Our button needs to remember, hey, I am currently clicked. I need to put an X in the box. So state will become more familiar as we talk about it more. But React components can have state by setting a state in their constructors. And state is considered as private to the individual component that it's defined in. So different components can be in different states at different times. So as if I click a single square, only that square has been clicked. And so only that square gets an X. None of the other squares care that I have clicked it, right? These squares should be independent of each other. Let's store the current value of the square in this state and change it when the square is clicked. Okay, so we're going to add a constructor to our class to initialize the current state. Now we remember constructors, right? classes and constructors. It was only what, like 6 months ago that we talked about that. Y'all remember that, right? So inside of classes, constructors can help us build objects. So inside of classes, constructors can help us build objects. So let's add a constructor. And yes, and we're also going to, and we'll also update our onClick to an arrow function. Yep, we'll do that too. So let's build our constructor inside of our square. Constructor, and what we're going to pass into that constructor are our props. Now we'll talk about the keyword super in a minute, but for now, just go ahead and add super and say props. And we set our state. And for now, we'll give it a value of null. And we're also going to change our button to an arrow function to match what's already here. So on click, oops, arrow function, make sure I get this right. Console log, move the brackets. There we go. Okay, that should be fine. So we're setting our state. And there's a note here that says, in JavaScript classes, you always need to call the keyword super when defining the constructor of a subclass. A lot of words. But just know that all React classes that have a constructor should start with a call to super props. Now, we have seen the keyword super before, but I wouldn't blame you if you didn't remember it. Essentially, all the classes that we're creating are extensions, right? We're saying class extends our component. And so since it's a subclass, we need to add the keyword super. Just know that for now. It's just inheritance, yeah. So don't think too hard about it. Just know that, just remember that you got to add the super keyword and you should be fine. No, now we'll change our squares render method to display the current state's value when clicked. Okay. So we're going to do a little replacement here. Inside of our square, we're going to update our button to change it to the current state. So class name is going to be square. And, oh, sorry, that's inside the button. Gotta keep the tags straight here. So they changed the formatting a little bit. We're gonna do an enter here, and class name square. On click, we're gonna set the value of the button on click to the current state, which is gonna start as X. Okay, this dot set state value X. Okay, so what are we doing here? Oh, wait, let me finish it first. And inside of the button itself, this dot state dot value. Okay, let's try that. And I'm missing a closing bracket. Okay, there we go. Okay, so now I can click any of these squares and get an X. So what did we actually do there? Well, we set the current state to be the value of X. And then on each click, we pass that value into our button. So we're just saying, all right, every time this is clicked, set the state value to X and pass it into our button as the button value. That's all we're doing there. So it's always going to be X because we're always setting the state value to X. Now, that state might stay the same, or it could change depending on circumstances. So we're pretty soon we're going to get into how we change that state um, to alternate between turns, right? Because that's going to be the point of this is we're going to want to alternate between X and O. So we're going to change that state depending on whose turn it is. And Gcomer says, yeah, if you don't want to remember class syntax, um, there's newer docs out there. I don't disagree. But we were actually, this is this is the documentation we were actually assigned to read for our course that we're in. So we do have to get familiar with this older syntax. I'm sure we will probably touch on newer syntax as well, though. Yep. The super calls the previous constructors up the chain. Yep. And so in this case, we're just calling a parent. Classes are the floats of React. Yeah. And we always got to start out learning the cumbersome stuff first, and then we get into the simple stuff later. All right. So we set our state, gave it a default value of X. So every time we click, X is what's going to be inserted into our button. So by calling this .set state from an on-click handler, we tell React to re-render that square whenever its button is clicked. So that's a little important thing to note, is so that we are not, re-rendering the entire page every time the button is clicked, right? We're just re-rendering the single button that was clicked and assigning it the state value, which is X. If you click on any square, an X should show up. And when you call set state in a component, React automatically updates the child components inside of it too. So if we had children in here, they would also be updated. And here it goes into a little interview afterward about developer tools for inspecting React. You can read this on your own time if you want. We're not really going to use it for this particular tutorial, but there's an extension you can install in Chrome and Firefox specifically for React. So that's up to you. All right, so let's make the game actually work. So we now have the basic building blocks. We have, functionality. We have a clickable button. But in order for our game to actually work, we need to place alternating X's and O's on the board. And we need a way to figure out who has won the game, right? So next we do something called lifting the state up. So right now, each individual square maintains the game state, right? Because we're setting the state inside of each individual square. To check for a winner, we'll maintain the value of each of the 9 squares in one location instead, right? Because to figure out who won tic-tac-toe, you can't look at an individual square. An individual square doesn't matter. What matters is how the whole board looks at a given point in time, right? Winning tic-tac-toe requires you to look at the entire board. So that's what we're going to have to do. We're going to have to modify the code to instead look at state as the state of the entire board. Now, we may think that the board should just ask each square for the square's state. Are you an X or are you an O? Although this approach is possible in React, we discourage it because the code becomes difficult to understand, susceptible to bugs, and hard to refactor. Instead, the best approach is to store the game's state in the parent board component instead of each square. The board component can tell each square what to display by passing a prop down to the child, just like we did when we passed a number to each square. To collect data from multiple children or to have 2 child components communicate with each other, you need to declare the shared state in their parent component instead. The parent component then passes the state back down to the children by using props. This keeps the child components in sync with each other and with the parent component. So we're strengthening that parent-child relationship by saying, hey kids, you don't worry about, don't worry about what your individual state is. The parent is going to be the one dictating what you should be displaying at any given moment. And that's a general principle in React, is that you want to centralize the state inside of the parents instead of having it in multiple places inside of each of the children. So if there's a parent controlling element, that's where you want to set the state. Single source of truth. Exactly. And we see that with code in so many different ways, right? We try to make our code dry. We try not to restate things multiple times. That's just the general principle. We don't want to restate something over and over and over again when we could just say it once, right? That's just a general coding principle. Don't restate when you can just say it once and apply it multiple times. Lifting state into a parent component is common when React components are refactored, so let's try that out. All right, so now instead of having our constructor setting the state inside of our square, we're going to move it up to the parent, which is the board. So inside of the board, we're going to add our constructor in there. So before render square, that's where we're going to add our constructor, attach it to the parent, and set the state there. Because it is the parent to all of the child squares, and so that's where we want to control the state. All right. Squares. We're going to set an array. Oops, 9 with no fill. All right. And then when we fill the board in later, that state array, so instead of just being a single value like X or O, now that array will look something like what they show us here. So O, null, X, 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 O, O, null, null. So now the state is of the entire board instead of an individual square. What that's going to do in this case, it's going to help us basically determine not only the history of past moves, but also who's winning. All right, now we also need to make an adjustment to the render method as well. Since we're now passing state down from the parent to the child, we need to adjust the render method as well. So in the beginning, we pass that value prop from the board to the square to display the values 0 through 8. So now we're going to pass the props again, except we want to pass the appropriate value for each of the board values. So we'll modify the board to instruct each individual square about its current value, whether that's X, 0, or null. We've already defined the squares array in the board's constructor, and we'll modify the board's render square method to read from it. All right, so we have an array that essentially says, here's the current state of the board. It's going to look something like this. And all we're doing is passing that into the child, saying, all right, you're going to be X, you're going to be 0, you're going to be null, right? All right, so return square value. And instead of just I, we're actually going to pass in this dot state dot squares I. So it's going to iterate through the array of values and pass the correct one into each square. Each square will now receive a value prop that will either be X, O, or null. So now that's all well and good. We can pass things down, but we need to change what happens when a square is clicked. So the board component now maintains which squares are filled, but we need a way for the square to tell the board that it's been clicked and it needs a value. Since state is considered to be private to a component that defines it, we cannot update the board state directly from square. So we're going to pass a function down from the board to the square, and we'll have the square call that function when the square is clicked. Okay, so we're going to make a quick change also to the render square method in the board. And render square is now going to become return value, this state squares, and then essentially saying, all right, on click, then handle that click. On click, gotta keep my capitalization right there. On click. Again, arrow function. Handle click. Okay. And close parenthesis. Okay, so you might be like, all right, what's handle click? Well, that's just a new function that we're going to write in just a minute. But first, I'm going to catch up with chat. Yeah, React Dev Tools are pretty great. And I'm sure we'll cover those in class. So that's why I kind of skimmed over it. I didn't want to get too deep in the weeds on that. The ghost of class components past plague us to this day. Yeah, the data flows down. Exactly. And that's what we're going to see a lot. You get it's all about the relationships between these components and the data flowing down, the props flowing from the parent to the child, state flowing down, controlling that state at the parent level so that all the children remain in sync. Yeah. Lifting state up is one of the most common refactorings one can do in React. Yeah, because I'm sure as your React components become more complex, as you add features, adding multiple components under the same parent, all of a sudden, maybe you only had one child before with no parents, and all of a sudden you have three components doing something the same. You want to keep them in sync, so you add a parent, and you have to move that state up to the parent. So arrow functions are a fairly new syntax. What's that site that we use for array methods all the time? I feel like it does a pretty good explanation of arrow functions. Yeah, yes. So 2015 is still pretty new, and you're talking in code terms. JavaScript.info. Yeah. So JavaScript.info has a pretty good explanation of arrow functions. They're just a different way to write, a more compact way to write standard functions. So instead of saying function, parenthesis, bracket, a bunch of stuff, and then a return keyword, we can just condense it down to say, here's what we're passing in, write an arrow, and then have an implied return. Yeah, and Rascal has linked so if you want to learn about arrow functions, Rascal has linked a link there for you. So it's just a more compact way to write a function. It doesn't behave, it's not anything particularly crazy. It's just a more compact way to write a function. Okay, so we're passing down two props from the board to the square. So we're passing the value that it should be, and then telling it what to do when it's clicked. So the onClick prop is a function that Square can call when clicked. All right, so now we just update our Square a little bit. First thing we're going to do is delete the constructor because the Square is no longer in charge of its own state, right? The board now controls the state, so we don't want a constructor anymore. And since we're passing something down to it from its parent, we're going to replace this .state.value with props. Because again, we're getting a property passed down from the parent. And we're also going to replace the set state with on click, because again, that's something that's being passed down from the parent. So this .props.onClick which is telling them what to do on click. So now it should look just like this. We've deleted the constructor because its parent is telling it everything that it's supposed to be doing. It no longer thinks for itself. The parent is telling it what to do. It makes the function wait until the event is actually fired instead of when the page loads. Yeah, and so that's why we're using an arrow function here, is because we're, these parentheses make it wait until the on click actually fires, instead of just firing when the component renders. Zombie component. Yeah. All right. So when a square is clicked, the on click function is called. So the on click prompt on the button, so they click a button and that's built in, right? It knows what to do on click. So on click, click a button, something happens. It tells React to set up an event listener. And when that button is clicked, React will call the on-click event handler that is defined in the render method. So we have an event handler set up. The event handler calls this.props.onClick. And what to do on click was specified by its parent. So that was passed down. We said on click, handle the click. Since the board passed on click, handle click to square, the square calls the board's handle click function when clicked. Now we haven't defined that yet, so the code crashes. So, and I've got maybe a missing parenthesis somewhere. Let me see. I usually do. Oh, semicolon. There we go. Had an extra semicolon. They'll get you. All right, so if I try to click on anything now, my code will crash and tell us that handle click is not a function because we literally haven't defined it yet. So as soon as this button is clicked, our square looks for this on click, which is defined here in the parent, and it says, all right, do handle click. Well, we don't have handle click yet, so that's the next thing we're going to do. Now that was a lot, but I feel like if you look at this, kind of, explore it yourself and see where the breadcrumbs lead, you can kind of get a feel for it a little bit. The parent is giving instructions to the child of what to do exactly when it is clicked. And so when it's clicked, our child is looking inside the parent to determine what to do. And we're telling it what to do right here. And this is just telling us that we can do custom names. So on click is built in, but we can have custom names such as handle click and define things that way. Hey, Pranjal, we're learning React today. Hey, Sagi, welcome. Yeah, we're doing a little bit of React today. Just getting started, just doing a little tutorial. Doing pretty well, Sagi, thank you. All right, so now let's actually add the function that's going to handle the clicks. Now, I'm going to scroll up just a little bit. So considering the relationship that we've established so far and the hierarchy that we know we know kind of who's calling the shots, right? We know kind of who's calling the shots. So if I'm going to write a handle click function, where do we think that handle click function will go? To actually give some logic on what to do when a square is clicked. So we have three components. We have the square, we have the board, and we have the game, right? So where do we think that handle click function will go? Yeah, this stream will be uploaded on YouTube, Pranjal. It'll stay on Twitch for 60 days, but it will go on YouTube eventually. Okay, so we've got one person saying parent, which is board, and the other person saying square. So anybody want to break that tie? Paradise says board. Okay. It would be called from square, defined in board. Yeah, yeah, right, exactly. Y'all are exactly right. Board has to handle the events from the square. Right, yeah, because the board is calling the shots. The board is the parent. It's passing, it's just literally telling the square what to do at any given point. And so by default, square is going to say, all right, what happens when I get clicked? Well, I'm going to look in my parent for what happens on click, and our render square method inside of the board is saying on click, well, handle the click. And so we're going to need to define a handle click function inside of our board in order to actually handle those clicks. All right, so inside of our board, we're going to go ahead and set up a new function called handle click. And set up our squares. And we're just going to give them a default value of x for now. And when they're clicked, we're essentially just going to pass whatever value we want to pass to them. All right, so on click, we have our handle click function set up. It's going to determine, depending on which square was clicked, it's going to do something different. It's going to essentially just say, all right, square's I is now going to become X. And inside of our state, we're essentially going to capture the state of the board at the time of click. We're going to set the square value to X, and then we're going to pass the appropriate value to the appropriate square. All right, let's see if we can click on a square to fill it. Yay, we can. They're still all X, but we've successfully moved that state up from the child to the parent. And now what we're doing is we're able to capture the whole game board at any given point in time, create a capture of it. And this will be important for later when we're trying to track the history of the entire game at any given point. Because remember, one of the main goals of this is to have a working history of the game that we can go back to at any given point. And so that was a big reason for why we want to move that state up to the level of the board. And that's essentially what we're going to be doing here by capturing or by slicing, taking a slice and filling it in appropriately. Catching up on the video, this is exactly what I needed. I don't like how Binary Boom was reloading everything like the comments. Yeah. And what React is going to do is going to help us with that, because we can have individual components that we load in at different times depending on how that state changes, whether that state changes or not. All right. Now the state is stored in the board component instead of the individual square components. When the board state changes, the square components re-render automatically. Keeping the state of all squares in the board component will allow it to determine the winner in the future. Since the square components no longer maintain state, the square components receive value from the board and inform the board when they're clicked. In React terms, the square components are now controlled. The board has full control over them. Now in handle click, we call slice, which is an array method, to create a copy of the squares array to modify instead of modifying the existing array. We'll explain why we create a copy of the squares array in the next section. And React is what is actually used for Instagram and Facebook, so that makes sense too. Yeah, yeah, exactly. React is used for, because if you think about Instagram and Facebook, they have tons of like modular components that are doing things at different times, and so reloading the entire page every time something changes just doesn't seem appropriate for an app like that, right? Yeah. All right. So remember that at each time a square changes, we're creating a copy of the entire array. And so why are we doing that? Like, why do we even care? Well, in the previous code example, we suggested that you create a copy of the squares array using the slice method instead of modifying the existing array. And that's called immutability. Again, good vocab word. And we know, if you're recalling what you know about array methods, certain types of array methods make changes to the existing array, while some create a new array, right? So it just depends on which array method you use. Some of them modify the existing array, and some create a new array. And so there are generally two approaches to changing data. The first approach is to mutate the data by changing the data's values. The second approach is to replace the data with a new copy that has the desired changes. And so they give a couple of examples here. For one, we can update a score in an existing object. Or if we wanted to leave the original object alone, we could simply create a new object and assign the values of the previous object to it. And there's several benefits to doing it this way instead. So we can implement complex features much more easily. This is going to allow us to implement that time travel feature where we can rewind to the previous moves because we have copies of that array at any given point in the game, right? We have multiple copies and we can just rewind to any of those copies at any time. This functionality isn't specific to games though. An ability to undo and redo certain actions is a common requirement, right? Think about how many times when you're using an application that you want to click the undo button and have it revert to its original state or just go back one step. That's super common. Undo and redo are really, really common features in apps, and using and using immutable functions can help us do that. Also, let's say we want to see if something actually changed. So detecting changes in mutable objects is difficult because they're modified directly. Detecting changes in immutable objects is very much easier. If the immutable objects that is being referenced is different than the previous one, then the object has changed. So at 2 points in this game, if I compare where we are at move 6 versus move 5, it's very easy to see that a change has been made. And okay, so why do we care? Why does this matter? Why all this talk about mutability versus immutability? Like, why does it matter if we know whether something has changed or not? So again, something very important with React is knowing when an individual component should re-render or not. Does that mean that's the benefit of React, right? We don't have to reload the whole page every single time one thing changes. Instead, we just see what's changed and re-render that thing only. And so the main benefit of immutability is that it helps you build pure components in React. So immutable data can easily determine if changes have been made, which helps determine when a component requires re-rendering. So if I have a bunch of components on a page, I want to immediately identify when one is changed and re-render only that component. So that kind of just helps us, accomplish one of the main reasons why we're using React, one of the main goals, to save resources and only re-render what we need to re-render. Okay. So that's why, and to kind of bring things full circle, that's why we're using slice, because what slice does, if you're familiar with your array methods, what slice does is it's creating a copy of the array instead of changing the original array. That's why we're using slice. All right, so now we'll change our square to be a function component instead. So, I know we all weren't, sorry, my dog is being loud. He's chilling out on the floor, and he always gets bored when I stream because he doesn't want to learn about React. He wants to go play frisbee. So, all right. So now that we've simplified, yeah, we like all the savings, yeah. So now that we've simplified our square class so much, we can actually change it from a class. It doesn't have a constructor anymore, right? So we can change it from a class to an actual function. So that's the next step here. We're going to change our square to be a function component. So function components are a simpler way to write components that only contain a render method and don't have their own state, right? Because the square does not determine its own state anymore. The state is passed to it from the parent. It doesn't set its own state. It doesn't need to be a constructor. So let's simplify it down into just being a function. We can write a function that takes props as an input and returns what should be rendered. Many components can be expressed this way. So we're going to replace our square class with just a function. This will look a little bit more familiar. And just like I said before, how I compared props to, arguments inside of a function, that's literally what we're doing here. The props literally become what we're passing into a function. And all we're returning from this function is just a button containing the appropriate value. So I'm going to copy and paste this because I'm probably going to get it wrong. All right, button. There we go. All right, so our button, giving it a class name of square, pass the click, and just display whatever value comes to it from the parent. And when we modified the square to be a function component, we also changed our onClick from this.props.onClick to a shorter onClick props.onClick. Because the props, it's what's being passed to it, just like we would with any argument from a function. It's just being passed in there, and we can just pull out the onClick from inside of it. So again, the reason why we were able to simplify this is because it's just taking in whatever input it gets from its parents. It's not setting any kind of state. It's not building anything. It's just taking in something from the parent. So we're able to simplify it down to just a regular plain old JavaScript function. All right, now we've kind of set up this relationship and solidified it and figured out who owns what. So let's fix it so that you can actually take turns in the game and lay both X's and O's. So the first move is going to be X by default, but then we want to alternate from there, XO, XO. The first move will be X by default. We can set this default by modifying the initial state in our board. So instead of hard coding our square value to X, we want to have it be able to alternate. So in the state value, in our constructor, when we set the state, we're going to declare a new value here called X is next and set that to true. And so each time we move, we're going to have a Boolean that flips from true to false and determines whether that should be X or O. So true, false, true, false, true, false each time a button is clicked, just to alternate between X and O. And so instead of in the handle click function, instead of that being hard coded to X, we modify it very slightly to just say this dot state, check the value of X is next, determine whether it's true or false, and use that to set the value of X or O. So again, very simple. We've done stuff like this before. It's just a ternary operator. And it just says, hey, check the current state, determine whether that Boolean is true or false. If it's true, it's X. If it's false, it's O. Makes tic-tac-toe a lot easier, right? Just flip a Boolean. And so, okay, that's all well and good. We can check that current state. And the last thing that we need is just something that will then flip the Boolean from true to false each time we move. So again, in handle click, when we set the state, we also need to flip the Boolean. All right, now with this change, we should be able to take turns between X and O. So let's try that out. Hey, because after each click, we are changing the current state of things, right? Remember, the current state is like a snapshot of where we are at a point in time. And so at this point, at each time we click, we update the state, we update that Boolean, and that determines whether the next move is X or O. And now let's also change the status so that it updates the next player to be X or O. So we can do that exactly the same way, just by checking the current state value and setting it to X or O accordingly. So inside of the board render, let's see, change the status text. Okay, here we go. So inside, when we render the board right now, we're just hard coding saying the next player is going to be X. Instead of that, instead of that, we set it to X or O. Come on. There we go. Instead of that, we set it to X or O, depending on the current state of the board. So next player. And I need, what am I missing here? This player. There we go. Okay, just took a minute to render. Okay, perfect. So now as I click, this should flip back and forth because the state is changing on each click. Yay. So the not makes it flip. Yeah. Let's see, where is that? Yeah. So the bang there, the exclamation point, essentially what that does is if you have like a Boolean that's like true or false, the exclamation point simply declares the reverse value. So if it's true, saying exclamation point true equates to false. It just flips it. Yep, that's all it does. That's a useful thing to remember. What that's for. It just declares the reverse value. Yeah, exactly. It negates the statement. Yep, to scale, exactly. Okay, so the last thing we're gonna do is we're gonna set up the winner, and then we'll take a break. So essentially after that, our game will function. And then after we declare the winner, we can set up the time travel and use the history and figure out, finally remember why we're taking all those snapshots of the history to create our multiverse of tic-tac-toe. All right, so let's declare our winner. Now we show which player's turn is next. We should also show when the game is won and when there are no more turns to make. So they want us to grab this helper function and copy and paste. Don't mind if I do. I love a good copy paste. And we're going to put it at the very end of the file. Sounds good to me. And all this is doing is manually declaring the lines, and it's checking to see if there is a winner. So if you do need to build a tic-tac-toe, this might be a useful little function to have. But it's really not doing anything that we haven't seen before. It's just checking all the values, looping through them, and finding a win scenario for tic-tac-toe. Given an array of 9 squares, this function will check for a winner and return X, O, or null as appropriate. So now we have a function called calculate winner. So we can call this calculate winner function, examine the current state of the board, and figure out when a win scenario has been achieved. All right, so we're going to replace the status declaration in the board's render function. Okay, so in render, instead of just status, we're going to have a whole function. So we're going to say const winner calculate winner. And in order to calculate the winner, again, we're going to look at the current state of the entire board at once. And if winner is true, so if a winner has been declared, if a win scenario has been achieved, then the status should just be showing the winner's name. Or the winner, whether it's X or O. Winner, show the winner. However, if the win state has not been achieved, then the status should be just next player. This state X is next, checking to see who plays next. So again, we're using state in two different ways here, right? We're using the current state of the board in two different ways. So for one, we're checking to see, we're looking at the whole board, looking at all the values at once and saying win state has been achieved or win state has not been achieved. And if win state has not been achieved, then we just look to see, is X next? If it is, show the value X. If it isn't, show the value O. So let's test this out. So that's still working, XOXO. Now I'm going to make O win here. Hey, so as soon as that game state achieves a winning combination, it's checking on each click, running it through our calculate winner function. As soon as that win state has been achieved, then it changes the text to show the winner. And then the last thing we're going to do is just make it so that somebody can't keep clicking after the game has been won. So it stops registering clicks after the game has been won. So last thing we're going to do before our break is we are going to change the board handle click to see if the winner has been, to see if the game has been won. And if it has, then ignore any subsequent clicks. So just a quick check there. If all right, so we're checking two things there. If the win scenario has been met, or if all the squares are filled, then exit the function. Else, keep going. So let's make sure that that's going to work. Okay, good. So I won the game there, and now it's not letting me click anymore. So I believe that's working as intended. Perfect. Okay, so we have a functional game now. Perfect, cool. Our board is successfully controlling the entire state of all the squares underneath it. It's able to check for win scenarios, and it is able to make. Sorry, my dog is fully asleep and is barking. He's barking in his sleep right now. He's completely fine. He's just dead asleep and barking. Shh, bud. Sorry, it's really cute. Bud, hey. Shh. Completely asleep. Yeah. Okay, I think it's break time. Um, but feel free to review this code during the break and see if you can wrap your head around it. I know it's a lot, but really the main concepts here are just that the parent is controlling the state of all the children and keeping track of the history. And we're going to be keeping track of the history of the state of all the children at any given point. And we're going to use that history in the next step when we add our time travel to go back in time and rewind the game at any given point. Again, this is just like a control Z, like undo feature that you find in a lot of apps. So I think it's a useful thing to remember why we're doing that. It's basically just undo. Poor dog. Nah, he's absolutely fine. He's very loud sometimes when he sleeps. Oh, thank you for the hydrate. All right, so let's take 5 minutes and digest this a little bit. And when we come back, we'll add our time travel and store the history of our moves, which we've already set up the infrastructure for. We just need to store it. All right, let's get started. All right, I'll see you back here in 5 minutes. I'm sure there is one, Xena. Okay, folks, come on back. We got about a minute left in the break, so work your way on back. And the next thing we're going to get into is looking at history, storing history, and revisiting that history. So, learning how to add undo capabilities to our application, to our component, I guess. He's never going to catch that squirrel before he wakes up. Yeah. While I was on mute, he woke up, rolled over on his stomach, made a really loud sigh, sort of groan noise, and he's gone back to sleep. So, all right, I'm going to go ahead and stop the timer so it doesn't beep at us. All right, so let's make it possible to go back in time to our previous moves in the game. And we talked earlier about mutating versus not mutating, versus mutating an array versus making a copy of an array. And if we had just had one array and kept updating it with different values, it would be very difficult for us, or impossible for us, pretty much, to store the history of all the previous moves in our game, right? Um, but instead, what we've done is we've used slice, which is allowing us to create a new copy of the squares array each time a move was made. And so that's making it immutable. Good vocab word to have in the back of your head, maybe on your Anki deck. This will allow us to store every past version of the squares array and navigate between our turns at will. So what we're going to do then is store all of our previous board configurations, all of those previous arrays, inside of a larger array. So we're going to have a nested array situation. We're going to have a big array storing all of our smaller board configurations inside of it, and then we can revisit any of those array elements at any time. And it's never going to be a very large amount of history, right? I can only click 9 times on this tic-tac-toe board. So there's a limit. So that's why this is very possible for us to just do a nested array and have a history array that looks something like this. So the first move, all the squares are going to be null. And then after the first move, one of them will be clicked, while the rest will be null, and then so on and so forth as more and more of the squares get filled in. All right, so when we're talking about history, if we recall, in the finished version of the app, we essentially want to have kind of a separate display to the right of the board where we have individual buttons that allow us to revisit the history of all of our moves at a given point. Right? I can just click through these and the board will update itself depending on where I click. Now, when we talk about who should own this history, when we talk about which component should own the history state, we have three components. We have square, board, and game. Out of those three, which component do we think should own the history state? Should it be the board? What do we think? Scrolling up to hide the answer. We have three components. We have square, board, and game. So if I want to store the entire history, display that history out here to the right, update the board based on the history. So in this case, I just conceptually, it seems like I'm dictating something to the board, right? I'm telling the board to go back to a particular configuration. I'm parenting that board maybe a little bit. What do we think should own it? Yeah, the game. The game is the parent of the board, right? If we're talking about the hierarchy, the game is kind of controlling everything, and the board is controlling the squares. So since this history is kind of dictating the actions of the board itself, which in turn dictates the actions of the squares, I think that, yeah, the game component should tell the board what to do, which then dictates to the individual squares what they should render in any given moment. Yeah, game should own it and pass it to props as to the squares as needed. Yeah, so passing it down, remember it always goes downward, flows downward from the game to the board to the squares. Yep. All right, so we're going to want the top level game component to display a list of the past moves right here. And it will need to be able to access the history that we're storing, the history of the game board at any given point. So we're going to need to place the history state inside of the top level game component. And since history needs to live in the game component, we're going to change state one more time. We've already moved state from the squares up to the board, and now we're going to move it one level higher to its parent, which is the actual game itself. Just like we lifted the state up from the square component into the board, we're going to lift it up one more time from the board into the top level game component. This will give the game component full control over the board's data, just like we talked about, right? Me clicking on this history dictates to the board exactly what it should do in a given moment. And it will let us instruct the board to render previous turns from its history. Okay, so just like we did before, we set our state inside of a constructor. So I'm going to do that. Right now the constructor is inside of our board, but I'm going to take it and I'm going to move it up to the game level. So taking it out of the board, moving it up one more level to the game level. All right, so now we're setting the state here. We're setting our history, initializing our history here. And setting our x's next value here, which will then be passed all the way down through the board into the squares. So now the board, since our state is now being set at the top level inside of the game, our board is going to need to be listening for some props, which it will then either send to a function or send down to the squares themselves. So we're just establishing the flow of data downward through each of these components. All right, we're going to have the board component receive our squares and on-click props from the game component. And we're going to need to pass the location of each square into the on-click handler to indicate which square was clicked. So we've deleted the constructor inside of our board, did that already. Replace this .state.squares with props, because props are being passed from the parent into the board. Oops, let's see, did I do that wrong? Hang on. Replace this .state.squares. Yeah, I need to change render square, sorry. All right, value this .props .squares, and then on click, handle click, and that should be all I need to do, because the parent is now dictating the actions of its child, which is the board. And now we need to update the game a little bit more to use the most recent entry in the history array to determine and display the game's current status. So now the game's going to use that array of history of all the previous configurations, grab the most current one, and pass that down to the board to say, hey, render this, please. All right, so inside of game, now we're going to add a few new things. We're going to add some consts, history, get the current state of the history of the board, and current to get the current value inside of that array. And all we're doing here is looking at the history array and getting the most current value. So we're going to look at the end of the array and grab the last value. It's pretty common. We should have seen this before when you're working with arrays. You should be familiar with, getting the last value in an array is just history.length minus 1, right? Because arrays start at 0. Get the value of the winner. So basically just checking to see if anybody has won the game. And then set the status, which we've already done before. So I'm going to copy that from where it was before. If winner, set status. And then instead of just rendering the board and expecting it to handle its own activities, since it now has a relationship with its parent, and the parent is the one dictating its state based on the history, we need to pass in some props to tell it exactly what to do. We're now telling the board what to do in any given moment. It can't make its own decisions anymore. So we need to tell it what to do at any given time. So instead of just rendering the board, I need to pass in what the squares value should be. School squares. And tell it what to do on click. Okay, and then the last thing is setting the game status. And now we're controlling all the decisions of the board at the game level, so we can remove any remaining code inside of our board that's making decisions. So inside of the render now, we can get rid of all of this stuff about setting a winner, because the board is not thinking anymore. It doesn't need a brain anymore. It's all done thinking. The game is what's making the decisions now. So the board is really just rendering whatever it gets from its parents, rendering each square, and doing whatever its mom tells it to. We're now telling the computer exactly what it can do with a lifetime supply of chocolate. All right. All right, the last thing we need to do is move handle click from board to game. I think I may have already done that. No, I didn't. Okay, so we can just extract handle click, because again, that's the decision, and our board isn't allowed to make decisions anymore. Our board's decision-making privileges have been revoked. Its mom is making all the decisions for it now, so it doesn't get to think anymore. It just gets to render stuff. So we'll take that out. and we'll move it down into the game. I don't know, who knows, maybe the board was making bad decisions and, just needed some, some direct supervision. So that's what we're going to do. And I'm going to drop it in there. I'm going to put it, let's see, where does it go? I just need to see where it goes real quick. So it goes after the constructor. Drop it after the constructor. Now the game is handling the clicks, and referencing history. Oops. We're going to make a few modifications to it because the game's component state is structured differently, right? Because it's referencing history. So we need to make sure it can do that. And current squares slice. Okay. Perfect. And then in the set state, we just add a little bit of additional code here to essentially add each history entry to the array after every click. Squares. And there. Okay, so what this is doing is after every click, we're adding a new snapshot of the game's configuration to our history array. So every time this is clicked, we add a new snapshot of the game's history so we can go back and revisit any element in that array at any time. My mom wishes that she could transfer that logic. Revoke decision-making privileges, transfer everything back to mom. I'm sure all moms wish for that, or parents, or guardians, or whatever. I'm sure all guardians wish for that capabilities at some point. And again, we're using concat here. So we're adding something to the array, but we're not using push. Normally, when we add something to an array, we would use push, right? Array.push. But in this case, we're using concat because it doesn't mutate the original array. And so now, since all the decisions have been taken away from our board, just like with squares, all that board is really doing is listening for things to be passed to it and rendering things. It's not thinking about anything. It's just listening for input and rendering that input. All right, so the whole point of this was to keep track of the history and then display it to the player as a list of past moves. So React elements are first-class JavaScript objects. We can pass them around in our applications. So we can use an array of React elements and render them just as normal. So in order to do that, we're going to use map, and we're going to map our history of moves to the React elements representing buttons on the screen and display a list of buttons to jump to past moves. So we're going to take our history array and essentially create a list, kind of like we've done before with like EJS or something like that. We've used EJS to dynamically generate a list with individual items in it. And so essentially that's what we're going to do here. So inside of our render method, we're going to not only display the board, but we're also going to display our previous moves. And I'm going to copy and paste this part because I'm bound to get it wrong. But we'll talk about what it's doing. Okay. Hang on. There we go. Okay, so we're going over each element in the history array. And what we're doing is what we're returning as we loop through each of these elements is list items with buttons that allow us to jump to the specific state that we specify. So it's going to allow us to jump to any state, previous state in the game's history. And then in order to make that work, we just need to tell React where to dump that list. So our moves list is going to go down here in our game info, and it's going to give us a warning. That's okay. That's expected. So as we iterate through our history array, our step variable refers to the current history element value, and move refers to the current history element index. All right. For each move in our history of our game, we create a list item, which is something we've done before with EJS. And it contains a button, and that button calls a method called jump to, which is going to allow us to jump to a particular point in the game's history. And we want to see a list of the moves that have occurred in the game and a warning in the developer tools console. So we're expecting a warning here. Each child in an array or iterator should have a unique key prop, check the render method of game. So for once, we have an expected warning. What does this warning mean? Well, when we render a list, React is going to store some information about each rendered list item. So when we update a list, React needs to determine what has changed. So if we remember, React really wants to be able to compare things together and make sure it can detect when changes actually occur, right? That's very important. It needs to know exactly when a change has occurred so it knows what components to update and when to remain static. So when we update a list, React needs to determine what has changed. We could have added, removed, rearranged, or updated the list items. So for example, they give us an example here. We have 2 list items. Alexa has 7 tasks left and Ben has 5. The list has been updated here, but the order has been changed. So Ben now comes first. We have a new entry called Claudia, and Alexa comes last. So if I was reading this, I can easily see that some of those items have been swapped. But our computer only does what we tell it, and it's not gonna know that. It's not gonna understand what happened there. And so in order to get around that, we can specify a key value for each item. And we've seen keys before, right? We know what they are. They're a unique identifier for a particular item of some kind. It could be, in MongoDB, we have our object IDs, which are keys. In SQL, we have, identifiers for each row in a table, which can be keys. And in objects, we can have keys as well, which are true unique identifiers. So React needs keys as well to identify each list item. And if we were displaying data from a database, Alexa, Ben, and Claudia's database IDs, so for example, a MongoDB object ID, that could be used as a key as well. So whenever each time we re-render a list, React takes the key of each item and searches for a match. And if that current list has a key that did not exist before, React creates a new component. If the current list is missing a key that existed in the previous list, React destroys the component. If 2 keys match, the corresponding component is moved to its new location. And so keys are very important. It allows React to maintain state between re-renders. If a component's key changes, the component key will be destroyed and recreated with a new state. So key is a special reserved property. We've seen that before. React automatically uses key to decide which components to update. It's strongly recommended that you assign proper keys whenever you build dynamic lists. If no key is specified, React will present a warning, as we see here, and use the array index as a key by default. However, it's not recommended to not have a key. So in this case, we're going to specify a key for our list so that React knows how to match each item in the history and find the appropriate game state. Okay, so inside of the render method for game, let's go ahead and assign keys so that React knows where to find stuff. So in moves, all we need to do in order to assign keys is to just say, hey, inside of each list item, the key is just going to be the move value. Now you can see as soon as I specified the key keyword, the warning went away. It's like, oh, thank you. Thank you for specifying a key for me. However, we're not quite done yet because we just need to create our jump to method, which is going to actually execute the jump to a particular move. In order to do that, we essentially need to specify the step number to indicate which step we're currently viewing. Okay, so inside of our game, we just add one more thing to the state here. Start our steps at 0, and we'll increment each of those as we go. Okay, so after handle click and before render, we're going to add one more method here called jump to, which is going to allow us to jump to a particular move when we click on the appropriate button. So jump to step. And as soon as we jump, we're going to need to reset the current state. Set the step number. And determine also what the next move should be. So if I go back to move 3, if I'm on move, let's see, if I'm on move 4 and I go back to move 3 and I start clicking again on the game board, I want to make sure that I'm not putting an X when I should be putting an O. So I also need to reset my X is next Boolean too. Oops, X is next. Check and see whether our step is even or odd. And reset the value to true or false appropriately. We've done that before. Yeah, and there was a question about using this as for calling state. Yeah, and we kind of talked about that a little bit before. Class-based components is older methodology, but corporations or businesses often don't change quickly, right? They're going to be using older ways of doing things. You may be asked to, one of the first things that a lot of devs are asked to do when they get hired is refactoring old code, right? You're given a bunch of old code and they're like, fix this or make this better and or troubleshoot this. And so you're going to have to know how to parse the older methods of doing things as well as the newer methods so you can make things better. Yeah. Bye, Pranjal. Unless you plan to, I like the way Rascal said it there. Unless you plan to never touch any old code, you'll probably touch some old class components eventually. Yeah, absolutely. Okay, so now we can successfully jump. We can reset our XO counter if we need to. And inside of jump 2, we set a couple properties of our state. We set the step number back, and yeah, we set our X property. We didn't, but we didn't update the history property because we just jumped back. We want the history to remain in place. And leave that as is. So state updates are merged, or in simple words, React will update only the properties mentioned in set state, leaving the remaining state as is. We're almost done, Gluharski. Yeah, we're adding history to it now. All right. So as we move, as we click on each square, we want to integrate. We want to iterate our step number. So we click. We want to iterate that step number so it's keeping track of our game moves and adding a new entry to our list of moves that we can then click on and go back to. All right. So we're gonna, after we make a new move, we need to update step number by adding step number equals history.length. And this ensures we don't get stuck showing the same move after a new one has been made. Because remember, the game is now controlling what the board displays. So as we go one more step forward, we go to the end of our history array, grab the current configuration of the board, tell the board to display that configuration. The board tells the squares what to display individually, and that's how we iterate forward in our board configuration. So we also replace reading history with a slice. This ensures that if we go back in time and we make a new move from that point, we throw away all future history that would now be incorrect. Okay, so let's see how that works. Hey, Hope. Buenas tardes. All right, so instead of just this .state.history, we're now going to take a slice and truncate. If we've gone back in time, we want to make sure that we truncate our history and create a new multiverse, as we talked about before. And branch the new history of our moves off in the right direction. And now our state needs to also include the history containing the squares, the correct value of whether we're going to be clicking X or O next, and the current step number. Okay, so I think those should be almost all the components that we need. And then last thing, we're going to modify the render method from always rendering the last move to rendering the currently selected move. So instead of just looking at the last thing in the history array, we want to make sure that if we clicked on a different item in the game's history, to render that instead. So history is now going to reference the current state and the step number. Step number. There we go. Okay, let's see if it works. Whoop, handle click is not a function. Okay. Got an error somewhere. Just going to take a quick look at the code here, figure out where I went wrong. Handle click is not a function at 1435. All right. I'm imagining it's probably in here somewhere. You got on click. It should be handle click. Oh, okay. So down here, on click. Which component was that in, Seku? Let's see, 1435. Guessing that refers to line 14. Oh, I see what you mean. Yep, right here. Good catch. Seku gets an old a gold star. Okay. We'll get there. 40. Cannot read properties of line 40. Or is that line 58? 58, sorry. Current dot squares dot slice. Yeah. There we go. Hey, all right. So now we're keeping track of the individual moves. It stops when I hit a winner. And at any point, I can go back in history, accessing that history array that we created, and using the step number to figure out which part of the array I should be accessing at any given point. So we're using various components of the current state, which is more than just the history. The current state is like the step number. It's that history array containing all the previous game boards. And oh yeah, an averagely sized rabbit. That's a great question. What happens if you select a move to go back and try to play a new move? Yeah, so we're going to be creating some divergent history here. Um, and let's see, when we do that, when we create divergent history, so I'll just show you what it does. All right, so I'll just click down here. Yeah, so we see when I do that, it clears the previous history and starts creating new history. We're branching off in the multiverse here. So when I do that, it's truncating that current history and generating new history on top of it. So we're incrementing our step number by 1 and essentially replacing the value with the new state of the board. Yeah. It's going to overwrite anything past that index because we're rewinding. We're keeping track of our step number. And so as I click this, I'm going back in my step number. I'm going back in my step number and rewriting. So Peter Parker is coming along. Yeah, No Way Home. Great movie. Yep. Yeah, so we can see here when I render the board, when let's say I click on like move number 4, I'm referencing the current step number where we are, grabbing that appropriate board configuration from my history array and displaying that. And then when I display the moves, I'm going into the history, taking the step number and listing each of the items up to that particular step. I don't care about anything. If I rewind, if I go back to move 4 or move 3, well, I guess I'm still displaying all of them, but but then once I make another click, I'm rewriting history. So I'm only display. So I restart the count, right? My step number increments to move 5, and I'm restarting the count from that move. All of them, yeah. Is render a React specific function or a called function, or sorry, a created function where we gave the function a name? So no, we didn't define React at any point. We were able to just use it as is, built in. So let's see, render. Let's see, where's an example of that? So we can see here as I scroll through the code, at no point did we define render as a function. We were able to just use render as is. And return stuff from there. Okay, and I was trying to find exactly. I couldn't quite find exactly where we were when we were talking about truncating the moves and like creating a multiverse of moves. Um, Inside of the handle click function, so let me go there. Inside of the handle click function, we set the history by taking a slice of the existing history and essentially grabbing the existing history array. So when we go back in time, we want to grab the existing history array and only take a slice of the array up to that point. So that's what we build off of going forward. So that's what we're doing here. This.state.history.slice, grab the step number and slice the array from the beginning to the move that we clicked on. Does that make sense? So we're literally truncating the array up to that point. Okay, cool. Good deal. All right. Whew, that was quite a thing, wasn't it? But um, like we said before, the point of this is not to completely understand or react. The point is to kind of introduce some common concepts, such as these relationships that we have between components, the importance of immutability. So making sure that React can compare the previous state to the current state and determine whether or not it needs to re-render something. Um, because again, the whole point of using React is to create these reusable components that can kind of update themselves independent of each other, pass these props between parent to children. It's reminding us that props flow in one direction, and the parent should control the current state. The parent should control the current state of the children underneath it, right? In this case, our game as a whole, our game is dictating the behavior of the board, and then the board is simply telling the squares to listen to what's being passed to it from the game, right? We have this hierarchy of behavior, whereas the game is saying, hey board, go do this, and the board is simply passing those orders on down to the individual squares to tell it whether to be X, O, or null. Because the game has a lot of things it's controlling here. It's controlling how much history is displayed. It's controlling what the board displays at any given moment. It's controlling whether a winner has been established and what the next value should be. So in this case, the game is holding on to the current state of this entire game. And then it's passing those state values down to its children, whether it, down to the board, which then passes values down to the squares, etc. So this is just introducing some concepts that we're going to see in React quite a bit, explaining them in plain language, showing you how to apply them. And did you explain what lifting the state is? Yeah, we actually used it for the game. So the way the code started out, the state was originally dictated in every single square. So every single square in the game grid here was keeping track of whether it was an X or an O. But the problem with that is that if we did it that way, we would have no way of easily determining who the winner was, right? If each individual square was saying, well, I'm an X and I'm an O, how can I tell, when we have a 3 square match here? Because each individual square only knows, what it has inside of it. And so the first thing we did was we lifted the state up from the individual squares to the level of the board. So the board could say, hey, I know when there's a winner because I know the state of each individual square, and I just pass that state down, to the squares. The squares don't have to know what they are. I tell them what they are. And so that way I can determine the winner because I know I have, 3 O's going across here. And that's fine if we're just looking at the board on its own. However, we want other components here to know what's going on. We want to be able to tell the board to go back in time and find some history. So in that case, we lifted the state one more time all the way up to the level of the game itself, the game containing all of these different components that are here on the screen. And so that way, based on the user inputs, the game could tell the board what to do, which configuration the board should display at any given moment, and also, displaying this extra text and that kind of thing. Yeah. So yeah, the state started out at the individual square level. We lifted it up to the board, but that wasn't quite enough. So we lifted it up one more time, all the way up to the level of the game itself, so that the game was the one calling the shots based on the user input for history. My dog is being so loud. He's grumbling at me because, I'm standing here streaming instead of, going outside and having fun with him. He's just being a grumbly boy. Is context a good idea to cheat the drilling? I'm not quite sure what you're referring to there. I'm new to React, so maybe there's, some kind of a quick fix there that you're referencing. But yeah, Rascal's more familiar with React than I am, so no, you're good. I'm just learning. We're all learning. It's all good. I'm sure we'll get there very soon. I'm sure. But yeah, so this really is just introducing some concepts, again, such as state, immutability, history tracking, um, parent-child relationships, and passing props from the parent down to the children. Okay, so I think it's about time for another break. And when we come back, what we're going to do is we're going to go back to the documents that we were reviewing before, and we're going to learn more about some of these things we've talked about already, such as components and props, and talk about them in more of a documentation sense, right? We applied them already, and we heard them explained in basic terms. We touched on them. We saw how they're used. And now we're going to talk about them in a documentation sense. I want to get through at least the definitions for components and props, talking about state and event handling, I think, and then we'll reevaluate where we're at, and we might stop there because again, we're going to be talking about React a bunch in class. We might stop there. I don't know. We'll see. We'll play it by ear. Prop dealing, passing props through a component only for the purpose of providing it to a child. Context, there's a global-like state that allows for the saving and passing of data from a parent to a grandchild without going through the middle child. I got you. Okay, makes sense. All right, so let's take a break, and when we come back, we're going to go back to the documentation, hear about a few definitions, see a few simple examples, and essentially just kind of review what we already talked about, but using more of the proper vocabulary terms. So keywords, yeah. Let's do it. All right, 5 minutes on the clock. Um, when we get back, documentation, everybody's favorite thing. All right, see you back here in 5. All right, folks, come on back. Got about 30 seconds left. Just enough time to grab a drink of water or pet your dog or whatever you want to do. All right, we'll go ahead and stop the timer so it doesn't beep at us. And now we're going to get back to the documentation. Yeah, baby. All right, so we touched on several things in that tutorial, such as components and props. And now we're actually going to look at the documentation and get a closer look at the definitions of those things. So good conversation here in chat about building things, what you can build, and yeah, you can build really anything that we've built already in class. Rascal had some good suggestions there. To do apps, CRUD apps, anything. I mean, you can translate it over into React. Um, and React itself that's a good point too, something to touch on. React itself doesn't do things on the back end. Um, it's sort of like you're combining your templating language directly with your client side JavaScript. Like you're smushing the two together into a single sandwich. And yeah, React itself is not a language. It's a framework for JavaScript. So you're just kind of it's just a new way of envisioning our front end for our apps. Hey Dumpster, welcome to the stream, Fayaz. All right, so let's look at components and props. We've already applied them. Let's look and see what they actually are. So components are letting us split up our UI into independent pieces and look at each piece in isolation. We've already kind of seen that. Splitting things up into chunks and potentially, uh, rendering those chunks independently, updating those chunks independently, that kind of thing. Um, so conceptually, components are similar to JavaScript functions. They accept inputs called props and then return React elements to describe what should be displayed. And so a component can be a function, and it accepts a prop and returns a React element. They're literally JavaScript functions. There's no difference. It just, instead of argument, we call it a prop. Or we could also, define it the way we did with several of the components inside of our Tic-tac-toe app. We used class instead. Class welcome extends component, and then render whatever. And these two components are equivalent from React's point of view. All right, so previously we looked at, setting elements directly equal to existing HTML tags, such as div or section or H1 or H2. But as we saw with our tic-tac-toe game, we can also create our own tags and then pass props into those tags. So in this case, this tag is called welcome, and we're passing in a prop called Sarah. So when React sees an element representing a user-defined component, it passes JSX attributes and children to this component as a single object. We call this object props. So this code renders hello Sarah on the page because we're calling it here as welcome, passing in the name Sarah, and then returning hello Sarah. So we call root.render, passing welcome name equals Sarah. React calls the welcome component with name Sarah as the prop. And then our welcome returns an H1 with hello Sarah, and the DOM renders that. Hi Sarah, indeed. Hello to any Sarahs out there. And always start component names with a capital letter. So just a little naming convention there. React treats components, okay, so this is a good distinction. React treats components starting with lowercase letters as DOM tags. So when we define our own stuff, we should capitalize it so that React can identify it properly. So if I, in our tic-tac-toe app, we had a component, a custom component called board, and that was capitalized because that's not an existing DOM tag. We made that ourselves. In this case, welcome is capitalized as well. So components can refer to other components in their output. So this lets us use the same component abstraction for any level of detail. A button, a form, a dialog, a screen. In React, all of those are commonly expressed as components. So, like we saw before with our tic-tac-toe, right? The game rendered the board, and the board rendered multiple squares, like 9 squares. And so that's what we're seeing here is that our app component can call the welcome component multiple times. So it's kind of like how a function, a JavaScript function can call other functions, right? We can call function within a function if we want to, and that'll work just fine. Yeah, and as previously mentioned, as Breakpoint says, function components are the preferred method for modern React apps. Yep. But as we said before, we should still know the old way of writing them. We should still know, like, the class stuff and all that, just because we should know the different ways that those things can be written, just because when you get hired you might be asked to refactor code that's fairly old, and you should know how it looks and what it does. Reusable components modified by props. Gluharski, so if you want some free APIs, there's a GitHub out there that actually contains a massive list of free APIs. I'm sure somebody will be able to find it, but yeah, there's lists of tons of free APIs out there, that you can access and build apps off of, um, that are pretty great. And I know there is at least one GitHub that has compiled a a massive list of APIs that you can reference. So many people are very generous with their data and allow us to access it for free. So that's the wonderful thing about the internet, right? Yeah, I think I think that is the one there, Rascal. Public APIs. Yep. So definitely check that out, Luharski. So typically, new React apps have a single app component at the very top. But if you're putting React into an existing app, you might start just replacing a few components at a time. So somebody asked about that earlier. They were like, but what if I have an existing app and I want to add React to it? Well, you can. You might start with something small like a button, um, or maybe a little insert, maybe a single section you want to replace with a React component. And you could do that as well. And you can also split components into smaller components and reference those, inside of your larger component. So here we have a fairly confusing component called comment, and it's returning a bunch of stuff. It's returning comment, user info, and avatar, nested all together, username, comment text, and a date. It takes in an author, text, and date, and describes a comment on a website. And it's very confusing to look at. It's confusing to read, and so in the spirit of components and compartmentalizing things, we can extract this out into multiple smaller pieces and just reference those pieces when we need to. Starting from the bottom, yeah. Starting from the bottom, now we're here. Yeah, exactly. Yeah, and you totally can. So first thing we can do is what they're doing is they're extracting the avatar component. So extracting this part into its own component, taking that out. And because the avatar doesn't need to know anything else, it only needs to know the URL and the username. So it doesn't need to talk to any other parts of this, so it can be its own component. And now down here, since we've extracted avatar, we can just essentially reference it here like we would a function, right? This is very similar to taking a giant function that's really complicated and breaking it out into several functions and just calling the other functions when appropriate. So we've done stuff like this before. It's just refactoring. You take it out, take out components that don't need to be there, separate them out, and call them when you need them. So here we're doing that. We're calling avatar, passing in the author name, and we can also extract the user info. So using always the function name or the element name with the prop name. Yeah, so in order to be, as they mentioned earlier, I think in order to be a valid React component, it needs to have a name and then at least one prop, I think is what they said. So that's what we're doing here. Referencing avatar component, passing in the user information. So once we extract that as well, we're extracting user info. We've already extracted avatar. Now we're extracting user info. And so now comment becomes fairly simple. So we'll look at this on CodePen in just a second. So we have comment, which references username, passes in the author information, and then, user info passes in the author information. And then inside of user info, we're calling avatar, which again passes, well, I guess that's some different information there, but passing additional props into avatar. So we're nesting here again, just like we did for our tic-tac-toe game. So we separate them out into individual components, but we call them as we need them. Extracting components might seem like grunt work, but having a palette of reusable components pays off in larger apps. So you could do things like have a button, a standard button that does a standard action. Let's say you have let's say that you have one of those like apps that you scroll for a really long time and you want a button that goes back to top at the end of each section. So you have long sections, you want a button that goes back to top. And you want to use that button 3 or 4 times on the page after, like, let's say after each news story, you want a back to top button. So you would extract the back to top button as its own component and just reference it whenever you need it. So again, it's similar to how we've made reusable functions in the past. If you have a function you want to reuse several times, just break it out and reference it when you need it. So let's look at this in CodePen real quick. It should be fairly clear. Oops. I love that. Hello, Kitty. I hope you enjoy learning React. Thanks, Kitty. I didn't do that. That's what's in the official React documentation, which I think is wonderful. Gotta love it. Okay, so we can see that we have our avatar component broken out. It's expecting some props. It's expecting an avatar URL and a name from the user object here. We have user info broken out on its own. It's expecting a user name and comment. Yeah, destructuring. Yeah, destruction can be useful. It can make code easier to read. Yep. And then comment is referencing. Let's see, where is it? Oh yeah, comment is referencing user info. We're passing in props.author. And then user info is in turn referencing avatar. And so in the end, what that comes out to is displaying the avatar, the user info, and all the other related information in one go, because each component is referencing the component inside of it. Yeah. So very similar to how we did the tic-tac-toe game. Now here we don't necessarily have any kind of state. We're not setting any kind of, it's a single state, right? We're not making changes on the fly in this way. There's no way for us to make changes. We don't have a form or anything. But we still have that parent-child relationship just because it makes it easier when we break these things out into their individual components. So I would highly suggest, as you're reading through the documentation, clicking into the CodePen and getting a better sense of the relationship between these elements. And then another note about props is that they are read only. And these functions are called pure because they don't attempt to change their own inputs. So, um, sometimes with JavaScript, we know that we can take something that we've passed in, such as like a variable, and update it to a new value and then reassign it back to its original value, right? That's something we know how to do. We can use something like the plus equal or the minus equal operator in order for us to take an existing variable, modify it, and reassign it to its initial value. And one of the most important rules of React is that all React components must act like pure functions with respect to their props. So we're not allowed to modify existing props and set them to a new value. Instead, what we do instead is we use state. So that's what we were talking about earlier with our arrays, right? We have those arrays of our tic-tac-toe values. So instead of just updating the existing array to change the board values, we use slice to create a copy of the array, store the old array, and just keep creating new arrays instead. Instead of changing the existing array, we didn't want to break the rules, so we created a copy of the array. So here again, we see that one of the rules of React is that the functions must be pure and not modify their own props. Yeah, so the function withdraw is not correct. That's right. So this function here, sum a b, is correct because it's not changing the values of a or b. It's just adding them together, right? It's adding them together and returning the results. This function, what it's doing is it's taking the account and adding the amount back to it and reassigning the initial value. So taking an account, or sorry, subtracting an amount value and reassigning it back to account. And that's not allowed. We don't do that because our values should be immutable, or that word we saw before, value should be immutable, and we should not be modifying the props that we're passing in. It should never modify its own props. Yeah, props are read only. Exactly. So that's a little different than what we've seen before, just working with pure JavaScript, right? It's like generally we don't really care. We can, change the value of something we pass into a function, no problem. Reassign it and then pass it to a different function. Just keep modifying, passing it down the line, that kind of thing. But in this case, not allowed with React. All right. So any last questions on props? Sorry, let me go back. We have a question there. Okay, so the first example is okay. Yes, the first example is okay. The first example is okay. And so, Seku, can you tell me why the first example is okay, based on what we've talked about? Why is the first example okay, Seku? If you don't know, that's okay. I'm just seeing if if it's making sense what I'm saying. Yes, it's respecting the props, exactly. It's not assigning the value of a plus b back to a, right? It's not changing these, it's just using them as a sum. It's just using them. It's not changing them, it's just using them and then returning the result. Yeah, exactly. Yep. Yeah, and we'll talk about averagely sized. We'll talk about state in the very next section. That's why we say that, yeah, you can't reassign back to the prop, but that's why we use state in order to make changes. Yeah. And we've already seen kind of what state can do for us with the Tic-tac-toe app. So let's look at state. So, the question is, all right, if I can't modify the props, how the heck do I handle changes? Because things are going to change, right? Like our components are going to change, values are going to change, results, outputs are going to change, that kind of thing. And so I think, like, how do we handle change? We got to be able to handle change. All right. So that is where state comes in. So previously, in order to update we had a clock, we had like a ticking clock, and I think, do I still have it open? No, I don't still have it open, but we had a ticking clock that would update itself every second. It would update, 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 and what it was doing, it was calling render to change the rendered output. Oh, and it's right here. So we were doing a tick, and each time the clock ticked, we were render, 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 calling that over and over again. And that's all well and good, but we want to make it better. So in this section, we'll learn how to make that component reusable and encapsulated. So this individual component will set its own timer and update only itself. And remember, that's the point of React, right? We want to stay within our components and have our components, change themselves when they need to change. All right, so we're going to change this a little bit. We're going to separate out the elements that don't change with the elements that do. And so the clock now is separated into two parts. So we have our clock function, which has our H1. Make that a little bigger. Sorry, there we go. We have our clock function containing our H1 and our H2, showing the string. And then we have a tick function, which actually does the ticking. So that's what that's going to do, is it's going to render our clock at a set interval. So set interval is going to tick it once every second, call our tick function, which is then going to call our clock function, our clock component, and render the clock. However, it's missing a crucial requirement. The fact that clock sets up a timer and updates the UI every second should be an implementation detail of the clock itself. So we want to write this once and have the clock update itself. We don't want to have the we don't want to have all these things be separate. We want to just be able to render our clock and have everything work and have the clock update itself rather than relying on other components. So in order to do that, we need to add state. So state is similar to props, but it's private and fully controlled by the component. Okay, so what does that mean? So props are passed in from the outside, but state is private to the component. It's self-contained. It all happens inside the component. We set our state, and it doesn't rely on things passed to it from other components. So we're going to take our existing function and convert it to a class so we can set the state, similar to how we did for the tic-tac-toe, right? In the tic-tac-toe, any component that needed to set its own state was a class, and we had a constructor, and we built the state, and then we were able to pass it to other components, or pass things to other components that didn't have constructors. So in this case, this should look a little bit familiar by now. We're setting up a class called clock and doing a render. So state can just change variables in the same function. Yeah, so well, if you're familiar with constructors at all in class, that's how they work. They stay within the class, and they allow us to build objects within that particular class. And can we think of state like a ledger? Yeah, I mean, I suppose so. It's a snapshot in time of the current configuration. I mean, I'm sure there's nuance to it that I don't understand yet. But yeah, I mean, that's kind of how we were treating it for the tic-tac-toe, right? We were taking snapshots and holding on to that history, taking snapshots of various components and holding on to the history. And then we were able to do comparisons between previous state and new state at any given time. So render will be called each time an update happens, but as long as we render clock in the same DOM node, only a single instance of the clock class will be used. This lets us use additional features such as local, state, and lifecycle methods. Okay, so now we're going to add state. So instead of relying on something coming in from the outside, so instead of looking for props, we're going to change our reference to reference state. So this is going to come from inside. The call is going to come from inside the house. We're going to add a constructor and look for a state. And like I said before, we're going to add a constructor. And that constructor is going to build the current date timestamp that we want our clock to render. So constructor, we always set super. That's just required. We need to set super. It's a subclass, so each time you build a constructor inside one of these classes, you're going to need to set super. And then the actual magic is happening right here. We set the current state to be whatever the current date timestamp is, and then our H2 here is listening for that. What's the current state? So it can render that in the DOM. Note how we pass props to the base constructor using super, and class components should always call the base constructor with props. Okay. So now since we're not passing anything from the outside, when we call clock, we can just call clock without passing any props to it. Because our state is setting the date internally inside of the component itself. All right, so what does that look like? We have our constructor, which is actually setting the timestamp inside the component itself. It's all self-contained. We're encapsulating it. And our render can use that. It says, all right, I know where that is. I've got the timestamp that I need. I'm going to drop it in this H2. And then all we need to do is just render that clock component without passing anything else to it. So we've encapsulated it. It's now completely self-contained. But the only thing this is all well and good, right? It does what we want it to do, but it's not going to update itself. So if I open this in CodePen, it loaded once. It gave me the right time. Now what? We still need a way for it to actually update itself, right? It's stuck, stopped clock. Okay, so we're still missing a component here. We need to set up its own timer and update itself every second. So we want to set up a timer whenever the clock is rendered, and then clear that timer whenever the clock is removed. So after each tick, when the clock is removed, before it's rendered again, we want to mount and unmount the component. So we can add some special methods there to do this: component mount, component unmount. And we didn't do that for the tic-tac-toe thing. I think because it's so comparatively tiny. But in this case, since we're going to be ticking this clock every second to save resources, I think that's why they're doing the mount unmount here. Reason we're using this keyword to set state is because we're on classes, and otherwise if you use set state, yeah. So I do realize like this is the older way of doing things, but I mean this is what we were asked to read, so I guess we're just gonna have to roll with it for now. Okay, so inside the mount, this is where we can set our interval. So this might be like, okay, why the frick did we set our interval here? Well, as soon as we render this clock, it has been mounted, right? The component, the stuff we wanted to render has been rendered. It's mounted, and so this function gets called. Component did mount, and now we start the timer. We start the interval. And so what that's going to do is it's going to start the clock, start it ticking, and allow the timer to update itself. And The unmount, let's see, what is the unmount doing here? We'll tear down the timer in the component will unmount lifecycle method. Okay, so it's going to clear it. And then finally we'll implement a method called tick that the clock component will run every second. Okay, so let's look at this in larger context here. All right, so first thing we do is we set up our constructor, set the state to be the current timestamp. So that's what we saw here. It sets the state to be the current timestamp, and it passes that state to our timer when the page initially loads. And if assuming that everything mounts successfully, we start our interval, we start our ticker, and we clear the interval every time it ticks. So every 100 milliseconds, we call this tick function that sets a new date time object. So we're updating our state every single second and passing that state to the DOM. So that's what's allowing our timer to tick. So with our tic-tac-toe game, we manually set the state every single time we clicked on a tic-tac-toe box, right? That updated our state to something new. But with this, what's updating our state is our timer. Every second it's ticking and updating the date value of our state. Yeah. So now the clock should tick every single second. Let's see that. Yeah, and it does. What would happen if we don't unmount it? Well, we can try that. Let's see, can I just do, nope. Okay, well, that's fine. So it still works, and I figured it would. Yeah, it's not changing anything because and the reason why that still worked is because no matter what, we're still updating the state. The state is still updated. It's referencing that state and it's rendering whatever the current state is. So that still does work. It just seemed like they made it seem like this was best practice to do the unmounting as well. But that's why I like that all this stuff is in CodePen, so you can mess around and break it a little bit without fear of hurting anything. So let's look back at the definition for unmounting here. Let's see. So we want to set up a timer and then clear it whenever the DOM produced by the clock is removed. This is called unmounting. It'll only be after the component unmounts that the interval will still run. Calling set state on an unmounted or non-existent component causes errors. Okay, so why did that still work then? Even when I removed the unmount component. It'll only be after the component unmounts that the interval will still run. Okay, all right. Yeah. Okay. Yep, I'm with you. All right, so unmount is no longer render it, and the clock is always being rendered. Okay, yeah, so got it. So in this case, this is never being invoked because the clock is always on the screen. We're never not rendering the clock. The clock is always on the screen, so this is never being referenced at all. Correct? Yeah. I mean, you could write something that maybe would cause it to vanish if you clicked on it, but that's not currently part of the code. If you had a bunch of smaller clocks and then controlled a counter of how many clocks to show, if that counter went from 3 to 2, the third one unmount, calling this method. Okay, yeah, that makes sense. Is the component did mount function being called from React component? Um, well, so in this case, the component is mounted because it's on the screen right now. So that's why this interval is started, and that's why the ticking has been started. And after every second, our tick is being called, and it sets a new timestamp. We're updating our, we're calling set state. We're changing the state to the current timestamp, and that's what's being rendered on the screen. Oh, I see what you're asking. It's a method of React component which the custom component is extending. Yeah, so this is we didn't define this did mount thing. React automatically calls these lifecycle methods when the events happen. Yeah. So in this case, it's automatically being called once the timer appears on the screen. So it did mount, so we're going to call it and start the tick. Yeah. Good questions. Makes me think about it more too. Yeah. Yeah. It was being called when the timer appeared. Yep. Great question. Okay. So let's review again. So we're passing clock into root.render. And we're referencing a custom component called clock. How do I know, real quick recap, how do I know that this is a custom component? Let's say it was something that, maybe an obscure HTML tag that I didn't know existed. How do I know that this is a custom component? Just by looking at it. Yeah, it's uppercase, right? So by React naming conventions, if it's capitalized, that means it's custom and it's not a built-in tag. It's not a built-in DOM tag. So capital letter is custom component. So we're calling these mount and unmount methods from React component. Well, they're inside of our class clock, but yeah, they're built in. And as soon as the clock shows up on screen, did mount is called automatically. Well, if we have a button stopping the clock, we would use here actively unmount in the correct way here. Well, when you say stop, do you mean remove the clock or just stop it? And Aquita's, so we're calling these mount and unmount methods from React component. Yeah, so Rascal mentioned earlier, it's a method. So component did mount and unmount are methods of React.component, and we are just building our custom component, which extends React.component, and so we can use all of those built-in things like did mount and unmount because we're just extending React.component. So if you're familiar with classes, you can take an existing class and extend it, and make use of what was already there. Yeah, so if we're no longer rendering the clock, then yeah, it would be unmounted and we would clear the interval. So we would stop if we were no longer rendering at all, we would stop the interval that started when we mounted it. Hope that makes sense. That's what the clear interval is for. Yeah. Okay, so We're calling clock, which is a custom component, passing it to root.render. And so React finds that custom component and calls the constructor. And it finds that it needs to display the current time. So it initializes the state, the current state, and which builds in an object containing the current date time timestamp. And so then that initial timestamp is rendered, and React updates the DOM to match the output. So as soon as that clock output is inserted into the DOM, React calls the component did mount lifecycle method, just like we talked about, right? So the timestamp rendered, it's on the screen now, so it mounted. And inside it, we've said, all right, browser, please set up a timer to tick once per second. Start that timer. And every second, the browser calls the tick method. And inside of that method, we schedule an update by setting the state and updating the current time. Thanks to the set state call, React knows that the state has changed and then renders it again. Because again, remember, the whole point of React is it's looking for changes. It's reacting to changes to a component. And so here it's sensing, hey, set state has been called, the state has been updated, I need to re-render this component. And it calls render again to learn what should be on the screen. And our current state is different than what's in the render method. So the render output will include the updated time, and the DOM will be updated accordingly. And if the clock component is ever removed, as we talked about, React will unmount it, call that unmount lifecycle method, and stop the timer. So I feel like this is a pretty good summary. And it touches really on that whole thing about, how React is looking for state changes. If it finds a state change, it updates only what has been changed with the new state. And so here we talk a little bit about set state, which we just used. So 3 things you should know about set state. Do not modify state directly. So don't assign a value directly to state. What you should do instead is use set state. And that's what's going to trigger that check. And the only place where you can assign this dot state is the constructor. So that's what we saw in our timer here, right? We saw we initially in the constructor we initialize the state here, this dot state, but then later when we wanted to update the state, we use set state. So in our tick method, we use set state instead. Lots of S sounds. So we set it here initially. This dot state equals our initial timestamp. And then when we updated it, we use set state down here in our tick method. Okay, so what they're saying here too is state updates may be asynchronous. React may batch multiple set state calls into a single update. And props or state may be updated asynchronously. So you should not rely on their values for calculating the next state. Okay, so in this case, we're updating an existing state and using both props and the current state to increment it. What they're saying they should do instead is pass in set state. Let's see, use a second form of set state that accepts a function rather than an object. And take in the previous state as the first argument and the props as the second argument. And in this case, they're using an arrow function or a regular function to do that. Okay, I'm not sure I fully understand that one yet, but I'm sure, as we put this into practice, it'll become more clear. So I think what they're saying is just you want to, instead of assigning the current state and the up in the instead of taking in the current state and the props directly, just like they told us before, you shouldn't assign state directly. Take them in as arguments into a function and assign them that way. Okay. That's what I've been thinking 80% of the time. Yeah, that's okay. We're just experimenting with this stuff right now, right? We don't got to understand it. It's just, let's learn about some of these terms. Let's learn about some of the basic principles, some of the things we should and shouldn't do. And then we'll see how to apply them much more as we actually build stuff with it, right? Okay, so the next thing here, state updates are merged. And we actually saw this with our tic-tac-toe, right? Um, Occasionally when we did state updates, we would change, for example, we would flip the flag as to whether X or O was next, but we didn't necessarily change everything else about the state. We might have updated the history, we changed the XO flag maybe, but we didn't necessarily have to update every single element in that state. So what they're saying here is that state updates are merged. So React merges the object you provide into the current state. So here, this state has several independent variables. We've got posts and we've got comments. And so here we can update them separately. So the first time we set state, we just update the posts and the comments remain the same. So that makes sense, right? If I have a post with several comments, you might have people updating the comments like regularly, but maybe the post never gets changed. And so if you have those in the same state, you would only want to merge in the new comments and leave the post alone. This is where the reason is complex enclosure and scope. Don't try to understand, just follow. Yeah, right. For something like that, I'm just like, okay, fine. Tell me, tell me what to do. But for in this case, this actually makes sense in that if we update only a single part of our state, such as the comments, the state is still updated, but we just merge in the change. So that makes sense, like from a real world application. If I have a Facebook post with a bunch of comments, maybe only the comments get updated and not the post. And another thing we touched on is that the data flows down. So neither parent nor child components can know if a certain component is stateful or stateless. Okay. So state is local or encapsulated. It's not accessible to any component other than the one that owns and set this. And we saw that when we built the constructor, right? So we put our constructor inside of a class and it's not accessible due to scope. It's not accessible anywhere outside of that particular class. And so we set the state inside the class. It's not acceptable. It's not accessible outside of the class. That's just general scope principles from JavaScript, right? But we can pass it down to children inside of props. And that's exactly what we did with tic-tac-toe. So in tic-tac-toe, the board knew the current state of the board, right? It knew the value of all the squares inside of the board. And so what it did was pass the value of those individual squares down to its children. And it passed just the value that particular square needed. Pass it down to its children as props. Um, and that's what they're saying here. A component may choose to pass its state down as props to its children. So if I have a component and I set the state, I can pass it down to its child as a prop, just like this. The formatted date component would receive the date in its props and wouldn't know or care where it came from. It's just a prop, just like we pass something into a function. The function doesn't care where it came from. It doesn't care where its arguments come from. It's just like, all right, I have what I need. I'm going to do my function things. So I find that thinking about this in terms of like regular JavaScript functions helps a lot because it's the same behavior, right? Our function doesn't care where its arguments come from. It just cares it has what it needs. So this is called a top-down data flow. Any state is always owned by some specific component. Okay, we set a state inside of a class, but we can pass that downward to children if we would like to as props. Um, any data or UI derived from that state can only affect components below them. So any children. If you imagine a component as a waterfall, each component's state is like an additional water source that joins it at an arbitrary point, but also flows down. So in this case, what we have here is we have a component called app, and we are calling our clock component 3 times. And so inside of each of those clock components, as we saw before, we have a constructor. We're setting our time independently, and each of those clocks is ticking independently. Um, Whether a component has state or not is considered an implementation detail. You can use stateless components inside of stateful components and vice versa. And we saw that again in tic-tac-toe. Our game component set state, right? We set state inside of the game, and then our board and our squares didn't set state. They were stateless. We just passed information that they needed down to them from the game as props. So they were passed as props, and even though our board didn't set state, it was still able to pass more data down to each individual square because it already had what it needed from the game itself. Okay, I think we're about ready for another break. 7:15. I'm feeling pretty good. I'm clicking a little bit here, so it's nice that we can kind of apply this stuff back to the tic tac toe and see, as we get these more formal definitions, we can apply them to the things we've already done, right? Do I have foster kittens? Do I have foster kittens at the moment? Um, Flow state achieved. Uh, Technically, I do, Xena. They're at the shelter right now because, like I said, I was out of town. I was out of town for a few days this week, so I just took them back to the shelter just so they could, be taken care of while I was out of town. I will be getting them back this week, though. So, Xena, if you would like to name one of them, there are still two that need names. One kitten has been named Fig, but there are two that still need names. So I'll be picking them back up again this week here, and we can probably get that sorted out if you would like to. Yeah. Okay, so maybe we'll take a break and then we'll talk about handling events. That sounds good to me. Yeah. Okay, let's do that. Let's take a break and then we will go through handling events and we'll see how far we get in the next hour. Um, and then we'll decide, whether to stop or keep going. But I'm sure that we're going to be, talking about a lot of this stuff in class, so I'm not too concerned. But just, I'm feeling pretty good. All right, let's take 5 minutes. Go get a drink, go stretch, do what you got to do. See you back here in 5. All right, folks, we got about 30 seconds left in the break, so come on back and we will keep on trucking. All right, Aroni, I'm going to go ahead and stop the timer. And I had a snack over the break, and I hope that you got the chance to have a snack as well, or something to eat, or something to drink. It's important to stay healthy. I had some dried pineapple, which I love. So good. We're going to finish all the doc? Probably not. We're just going to see how far we get in the next hour or so. And that might be a good stopping point. Who knows? We're going to keep, React is something we're going to be practicing a lot. So I'm not super concerned about finishing the whole thing. I just want to give people a good head start and, a little bit of group practice, right? So, yeah. Got some really good dried fruit recently here from a wonderful little Amish store in my area. Okay, so let's get back to it. Let's talk about event handling. Handling events. So when we talk about event handling, what we mean is, I mean, stuff we've done a bunch of times before. When the user interacts with the DOM, there's an event, right? Or, like for example, a click or a select or a hover. There's something that happens. And so we want to be able to, React needs to be able to handle events just like our client side JavaScript might do. Um, so handling events with React elements is similar to handling events on DOM elements. So for example, clicking a button or clicking a hyperlink or something like that. There are some syntax differences. So different naming convention, camel case again, because React is more close to JavaScript than it is to HTML. And with JSX, you pass a function rather than a string. Okay. So if we were to be using raw HTML, in this case, if we had a button, we could specify an on-click action. And inside of that action, we could pass a function. Now, this is something that we haven't done very much in 100 devs, but it is something you see around. Instead of adding an event listener on the client side, you can just have an on-click event that passes to a function directly rather than adding an event listener and then calling that function. So this is something that's valid to do in HTML. It's not something we've done very much, but it does look slightly different in React. So again, you say on click, but you pass it using the curly braces instead of a string. And you notice it doesn't have the parentheses after it either. Cannot return false to prevent default behavior. I don't know that we've really done that very much, but you must call prevent default explicitly. So again, in default HTML, you can return false directly. In React, you have to call prevent default here. You'll see it in a fair amount of front end templates. Yeah, and I think that's really where I've seen it. If you're talking about on click, yeah, you definitely see that in templates. It's very common. But as far as our own projects that we've done so far, normally Leon pretty universally used event listeners on the client side. Yeah, on click. I'm going to kind of skim over the default thing here. Okay, when using React, you generally don't need to call add event listener to add listeners to a DOM element after it's created. Okay, so we've done this a lot, right? We create our DOM elements, our HTML elements, and then we add event listeners to them on client-side JavaScript. With React, we don't need to do that. We just provide a listener when the element is rendered. When you define a component, a common pattern is for an event handler to be a method on the class. For example, this toggle component renders a button that lets the user toggle between on and off. Okay, so here we have a toggle component. We're setting the state to be true. So toggle's on by default. And then we bind it to handle clicks and turn it off. So on click, again, we're using the exclamation point, we're using the bang to reverse that from true to false. And now when we render it, we just render the button, give it an on click, handle the click, and toggle on or off. So the button will say on or off depending on the current state. So that's fairly easy, right? We can just, as long as we've defined the method that it's calling, we can call that method, render the button, and it'll update itself automatically. Hey, Coding with Strangers, welcome back. We are still going indeed. We have done we're halfway through the docs and we even did a tutorial in the middle. So pretty rad. Yeah, there's a lot of binding going on here, and that seems like that just feels like old syntax to me. So that sounds like what Rascal is mentioning there. Forgot about all the fun bind calls of ye old React. Yeah, and so yeah, we're binding it. Looks like we're binding it to the parent, so we're binding it to uh, this. Binding is necessary to make the this work in the callback. Okay, I'm just going to take their word for it for now. All right, you have to be careful about the meaning of this in callbacks. In JavaScript, class methods are not bound by default. If you forget to bind this handle click and pass it to on click, this will be undefined when the function is called. Okay, all right. So if we don't bind handle click and pass it into on click, so if we pass this dot handle click into on click button, into our button, then it won't know what this means. Okay, I get it now. All right. So here we're kind of setting the this keyword when we bind it. We're setting the this keyword to have like a static reference, so it knows exactly where it is, and so then we can safely pass it into our button, and it will know where to find this handle click method. Okay. And yeah, this is not React specific. This is how functions work in JavaScript. If the bind annoys you, it does. There are two ways you can get around it. You can use public classes to bind callbacks. Okay. Class extends, handle click. This syntax ensures that this is bound within handle click. Okay, let me see what the difference is here. Class toggle extends React component. Oh, I see. Okay, it's making it public by using this syntax here. Handle click equals, and then using arrow function syntax. I vaguely remember that. It's been a while. Man, it's been a while since we've touched on this. It's been months since we've touched on this stuff. Oh boy. Okay, so public class helps bind this automatically, or you can use an arrow function in the callback. And this is what we did for the Tic-tac-toe app, is we used arrow functions in order to make that work correctly. So in the Tic-tac-toe, we didn't worry about binding. We used arrow function syntax instead inside of our onClicks. So I would say I kind of like this, seems like it's fairly slick. So just pass it in as an arrow function. It's bound automatically without having to say freaking bind or whatever. Just pass it in directly this way, the same way we did in the tic-tac-toe tutorial. That seems far better. But okay, of course there's a problem with it. A different callback is created each time the button renders. In most cases, this is fine. However, if this callback is passed as a prop to lower components, those components might do more re-rendering. Okay. So if we're passing it down lower to lower levels, there might be multiple re-renders um, and multiple callbacks. Interesting. That seems cumbersome. I'm sure there's better ways, but all the React professionals in the chat are probably screaming into their into their pillows right now. But let's move on. Okay, so passing arguments to event handlers. Inside of a loop, it's common to want to pass an extra parameter to an event handler. And if ID is the row ID, either of the following would work. So on click, pass an ID and delete the row. Or do you use the bind syntax and delete the row. So here it's using arrow function or using bind. The two lines are equivalent and use arrow functions or function prototype bind respectively. In both cases, the E argument representing the React event will be passed as the second argument. And with an arrow function, we pass it explicitly, but with bind, any further arguments are automatically forwarded. Okay. So multiple parameters, that's how we would do it with arrow function versus bind. That seems cumbersome was the foundation of motivation for hook-based functional components. Well, that's what Leon always says, right? You look for something that frustrates you and then you find a way to fix it, right? That's what you build your project around, is fix the thing that's annoying. So I'm glad that there's a solution, and I'm sure we'll learn what it is. I can be patient. Okay, so that was kind of confusing, but I'm going to remember the part of it that I'm going to retain for now until we learn something better is that if I want to define a click event, in order for it to bind properly, I'm going to use the arrow syntax, arrow function syntax on click, and have it bind to the appropriate method. Yeah, that's what I'll do anyway. Okay, so conditional rendering. Got a question here. It mentioned that using the arrow function technique of binding is recommended in the constructor. Was that noticed? Okay, let me go back. Oh, were you talking about here? I think I interpret all that to use arrow syntax in the constructor. I'm trying to figure out which farther down. Okay. So it talks about it using it here in the actual button. We generally recommend binding in the constructor. So they didn't specify arrow functions in the constructor. I think what they were talking about, yeah, I think what they were talking about is using this. So using this method here. So we're inside the constructor and we're binding here inside of the constructor explicitly. I think that's what they were referencing. I might be wrong, but I think that's what they were referencing here. Bind in the constructor to avoid performance issues if you are passing stuff down to children. But that's class binding. Can you use arrow function? Yeah, you can, and that's what we saw right here in this second example. So handle click was bound here with arrow functions, making it a public class instead. Tied for best is the bind or class method arrow function thing. Yeah, so like here, you can do it here as well, making it public. And then since it's public, we can call it here, no problem. Yeah, and RY, I definitely have seen the new docs. Unfortunately, this is an assignment we've been given for a course that we're in. And so explicitly, this is what yeah, we were told to read this chapter specifically. But yes, I am aware that there's newer methods of doing things out there. Generally, what we do is we start by learning the older way of doing things, and then we graduate to the newer way of doing things, just because eventually, as we move into the corporate world, there's going to be oh, no worries, yeah, no worries at all. That's totally fine. Just as we move into the corporate world, there's going to be a lot of companies that are still using the old ways. We might be asked to refactor code, that kind of thing, and so yeah, and so it's good to just recognize it, know what it is, know how it works, and then we get to use the good stuff later on. Yep. No, I appreciate you helping out, RY. Absolutely. No problem at all. In the login button function, there is handle click function. So this is talking about this here. Yeah, and that's why I know that we got folks coming in and out all the time, and so that's why I like to explain, why the heck are we learning all this old junk? Like, why do we even care about this? Yep. Yep. It's good to clarify that occasionally. Okay, so sorry, I'm going back to Seku's question there. In the login button function, there's handle click function. How does it know that it has to call handle click function? Well, this is just arrow syntax. This is just arrow function syntax. Um, this is just a different way of writing a function. It's a newer way of doing it. So this is just arrow syntax. So we're setting up handle click here as an arrow function, but public, we're making it public class field syntax. And if you want to read more about that, you can actually just click this link directly in the docs, and that should open the Mozilla docs. You can read more about it. Oh, you mean in the code picture down in the button element here? Well, because it's public, so this will not be undefined because it's actually public. At least from what I understand. If we make it public, it knows where this is located. It can find it outside and reference it effectively. So it's no longer private, it's public now. I think that's fairly new, isn't it? Oh, next picture? Okay, I'm sorry. Honestly, I like handling local state with class components more from a readability standpoint, but I get why it's better with functional. Yeah, and I think, Rascal, didn't you say that too? Didn't you say the same thing RY did? That it's easier to handle state with class versus functional components? So I mean, and I'm sure that's why we're starting out with class, because if it's more readable, then it's easier to, for us newbies to pick it up, even if it might be more cumbersome to work with. So Seku, is this the picture you're talking about? Oh, you're talking, okay, this right here. Um. Oh, okay, there. All right. So let's see. Okay, so in this case, we have handle click. We have handle click, and we're using an arrow function to call it from there. This syntax ensures that this is bound within handle click. Yeah, I'm not sure. I'm not entirely sure why that works the way it does. Exactly. I would have to read the docs. I'll be honest. I don't remember why this works. Just that it does. I would have to read the docs again on arrow functions. Hey, Bite Cookie, welcome. Hope you're having a good day. But they do provide a link to the docs here, so maybe that'll be yeah, no worries. Maybe that'll be a fun little side excursion for you. Okay, so we were looking at conditional rendering. Good questions, though. I like it. The React docs are being completely revamped pretty soon. You won't be seeing class components at all in the docs quite soon. Oh, interesting. So they're going away entirely. Wow. Well, like we were just talking about, byte cookie. It's a lot of us are trying to, well, not me, but a lot of the folks in the chat are trying to get, hired as full stack developers, React developers, that kind of thing. And so it is, I think it's valuable for us to learn about this type of notation. But yeah, I can see why it's, considered outdated from a modern sense, definitely. And Rascal says, so the arrow function keeps its lexical scope, which includes the this of the current component. So okay, so it locks in the this inside the arrow function itself. It keeps the this static. Okay, that makes sense. Yeah, and we will see. That's the point. Is we're going to see classes in the wild, I'm sure, and so we need to know how to identify them before we go on to the more modern methods. Yep. Okay, so let's look at conditional rendering. In React, you create distinct components that encapsulate the behavior you need. So we've already seen this, right? We've already seen how we can take chunks out, encapsulate them in their own components, and only call them when we need them or call them multiple times. Then you can render only some of them depending on the state of your application. Yeah. And that's, again, we also talked about that, right? You want to keep track of your state so that you know only what components need to be rendered at what times, right? You don't always want everything to render. Sometimes you only want one thing to render, and keeping track of state can help determine that. And having separate components can help with that as well. So you can use JavaScript operators like if or the conditional operator to create elements representing the current state and let React update the UI to match them. So here we have two potential greetings, one that says welcome back and another one that says please sign up. And so inherently we can tell that these are kind of going to be mutually exclusive, right? If somebody's coming back, we don't want to tell them to sign up because they've been here before. So what we're going to do is create a greeting component that can reference both of these other components depending on a particular condition. So in this case, we're checking to see if they're logged in first. And if logged in is true, then we return the greeting for a logged in user. And if not, then we return a greeting from a guest. And since we're using the return keyword here, as soon as we invoke that keyword, right, we're kicked out. We're done with the function. So in this case, we don't need an else because we're using return. Death to React class components. Who are we going to task with converting all the old class ones then? Yeah. The code will maintain itself. Yeah. Some brilliant coder will create a conversion app. Yeah, probably. No. It'll some brilliant coder will create a conversion app. It'll get sold to like some big consulting firm or something, or one of the big corporations, and then they're going to charge companies, through the nose to have consultants then do the conversion. So that's how that works, right? Some brilliant mind creates an app, sells it to a big corporation for a few $1,000,000, and then the big corporation in turn gets to employ a bunch of consultants and charge companies again much more money to actually implement the conversion. So that's how that works. At least in my experience. Okay, so we create our greeting component, and depending on the particular condition, we return either the user greeting or the guest greeting. And it renders a different greeting depending on the value of is logged in. So that makes sense, similar to things we've done before, using conditionals to return a value depending on, some input or other. And we can also use variables to store particular elements. And this could help us conditionally render a part of the component while the rest of the output doesn't change. Aha. Okay, so here we have some login and logout buttons. We're passing in some props. And we have the option to either return a login or a logout button. Okay, fair enough. In the example below, we'll create a component called login control, and it will either it will render either login button or logout button depending on its current state, and it will also render a greeting. Okay, so let's see what that does. We have our constructor, and it's handling our clicks for us. By default, our users are not logged in. And we have our components that are handling the clicks. So handle login click, set state, is logged in as true, or set state is logged in as false. So when they click login, it will set the login state to true. If they click log out, it will set login state to false. Okay, understanding so far? So we're setting a variable, and inside of that variable, we're storing the current login state. And then we're checking to see if they're logged in and grabbing the appropriate component depending on that condition and storing it in a variable. Okay, so that makes sense. All right. So if they're logged in, we want to grab the login button component. If they're logged out, we want to grab the log out button component. We're going to store it in a variable and then send that variable to the DOM containing whichever component we put in there. So it could be either one, but either way, we want the layout of the page just to remain the same. So we're going to send our greeting just as a pure component, but then we can also send a variable containing one of two possibilities, depending on the condition. So that's interesting. We can send a variable containing a particular component. Nice. We could also use inline conditions in JavaScript, in JSX, as explained below. Okay, so instead of using if else, as with JavaScript, we can make things shorter by using ternaries or logical operators. My React apps are full of short circuit operators. Oh yeah, I remember short circuits. Yeah. Um, From a templating perspective, you can do almost everything React does here with EJS or your favorite templating languages, annoying look or syntax notwithstanding. Yeah, it might look like crap, but you can do it. Yeah, so in order to make things a little shorter, you can embed expressions in JSX by wrapping them in curly braces. And we talked about this earlier, right? You can, as long as you have the curly braces, you can embed expressions. And so what they're doing here is they're creating an expression. This looks a little bit familiar for the type of things that we did in EJS, right? You would have your expression, and you would bind it in the crocodile carrot things with the percent signs. And so that's what they're doing here. They're doing directly inside of the return statement. They're doing a conditional check to see if we have any unread messages, and then if we do, we want to display a separate H2 header. And that whole expression is inside of curly braces, and so it will be executed inside of the return. It works because in JavaScript, to and an expression always evaluates to expression, yes. And false and an expression always evaluates to false. Yeah, and that's just JavaScript, basic JavaScript logic, right? Excuse me, treats this as truthy and treats this statement as falsy. If the condition is true, the element right after the and, so in this case, an entire H2 header, the element right after the and will appear in the output. If it is false, React will just skip it. Note that returning a falsy expression will still cause the element after and to be skipped, but will return the falsy expression. Okay, so in this case, we have a div and we're checking a count. And if that count, I guess if the count is greater than 0, that evaluates to truthy. So our H1 should display. But if our count is truly 0, that evaluates to falsy. So our H1 will not display, but the 0 will still show up. Yeah, short circuit operators. Yeah. This is why I always use a ternary instead, never a risk of this. Yeah. Um, yeah, it just depends on what you're trying to do, right? Are you trying to be super compact? Um, Here, actually, the very next thing they talk about is ternaries. Uh, I've, I mean, personally, I feel like ternaries might be a little bit of a less of a risk of having a condition that you don't expect. But everybody has their preference, right? I personally, I guess, if I have to do inline, I personally like ternaries. But everybody has what they like. So in this case, we already know how ternaries work, right? We can check, we perform a logical check of some kind, and then if true, currently, and if false, then not. And it costs a few more characters and has a certain look. Yeah, I also feel like ternaries are easier, maybe a little bit easier to spot. So you can pick them out a little bit more easily, but again, it's personal preference. Um, So I feel like most of us probably know how ternaries work already. Basically, it's just the same as a regular JavaScript ternary, except you wrap it in curly braces. Um, and that's what they're doing here. Again, a ternary wrapped in curly braces, true, false, hooray. Um, it's up to you to choose an appropriate style based on what you and your team consider to be more readable. As with most things in JavaScript, it's really up to the user and up to the team. And when conditions become too complex, it might be a good time to extract a component. There it is, piece of sheet says, yeah. And you'll find that, a lot is that no matter how you like doing things personally, your employer is probably going to have some sort of guidelines for you. So they might have a style doc. They might have, so for example, my employer has a code review that we do. Prior to me even releasing into a development environment. We have a code review. Certain style guides, certain style parameters must be met. Certain headers need to be on files. Variables need to be named a certain way. Things need to be formatted a certain way. Just for consistency's sake. It may not be how I like doing things. It might be like, oh, I gotta change my variable name to fit this naming convention. I mean, I think it makes it look less I think make it look confusing or what have you, but that's the naming convention. Like we stick to that. And so, you find that employers will have certain ways that they define you need to do things in order to keep things consistent for everyone. Okay, team, what do we want to do? Flips a coin. Sometimes it's like that, but most of the time there's going to be some set rules. Okay, so in rare cases, you might want a component to hide itself even though it was rendered by another component. To do this, we can return null instead of its render output. So in this example, warning banner is rendered depending on the value of a prop called warn. If the value of the prop is false, the component does not render. Okay, so let's see what it's doing. So we have a component called warning banner, and if that is false, then return null. Okay, else return a warning. Okay, and so here we're setting show warning is true, and we're using the toggle to toggle the state of show warning, true or false. Okay. I think I need to, we'll try this one in CodePen to see what it's doing here. Okay. All right. So it's just toggling the warning banner on or off. And if we want to hide something, we can have it return null instead to hide it. That makes sense. Returning null from a component's render method does not affect the firing of the component's lifecycle methods. For instance, component did update will still be called. Okay, yeah. So we return null. And that's still, even though we return null, it's still considered an update. And so the life cycle continues. Cool. Okay. So I'm thinking we might wrap things up for now. We're just getting into the juicy stuff here as far as lists and forms and lifting state up. So these are going to be kind of the application type things that we're going to be doing, including a nice example, yet another example of how to build essentially build a table and build a search box, a table. And like a little mini component, a collection of components inside of React. So I'm thinking we might save this until Wednesday. When we come back, we're all fresh, we're raring to go again. Well, on Wednesday, I think what we'll probably do is a brief review of what we talked about, like not getting into this much depth, but reviewing the common terms, talking about the various vocab words that we learned. On Wednesday, we'll do a light speed review, and then we'll get into more in-depth stuff talking about lists, handling arrays, kind of like we did for the Tic-tac-toe app, talking about forms. Forms are obviously very important for a lot of our apps, right? Talking about changing states, moving states up, composition versus inheritance, and then doing an exercise. So that's what I'm thinking. We're going to get into the juicy stuff on Wednesday. You're welcome to read ahead, of course, but I don't want to, drive us into the ground mentally today. So, is there TDD in front end other than E2E browser based? Don't think I can recall testing often used in JavaScript front end. I don't know the answer to that. Maybe somebody else does. I am actually for those of you who may be new to the stream, I'm actually a back-end developer. So I'm a SQL developer by day. So I am learning all this front-end stuff brand new. Yeah. So yeah, I'm a senior SQL dev getting into web development and front-end stuff for funsies. So yeah, a lot of this is pretty new to me. Still fun though. That's why I do it. So before we wrap up for today, I know we covered a lot, right? And all this, again, the intent of this is not to suddenly understand React. The intent of this is to introduce concepts, introduce terms, um, introduce behavior, and kind of have it in the back of your head so that when Leon talks about it in class, you can be like, oh yeah, I've seen that word before. I know what props are. Um, I know how we can pass things from a parent to a child. I know what component means. Um, and I know how we can write a component. And I know what the word state means. And so that'll just give you maybe a little bit of a head start for class. And then, yeah, on Wednesday, the plan would be that we'll probably get back we'll start with lists and keys. We'll do a review of terms. Then we'll get into lists and keys, forms, state, composition, and then we'll actually do an exercise which kind of sums everything up together. I need to go back to the tic-tac-toe practice and try adding comments to each line. Props and listing state and set state still feel a little confusing. Hopefully I'll be ready for Wednesday's stream. Yeah, and again, it's going to be more of just introducing concepts and just rehashing this stuff, doing some space repetition. And I'm sure, as always, Leon will do a great job on Tuesday of reintroducing this stuff and covering it again. So, any other questions? Yeah, exactly. Don't forget on Tuesday, MVPs are due for 100 hours projects. So don't spend too much time on this. Um, I just wanted to introduce it today, but I don't feel like everybody should comprehend it at this point. I certainly don't. So still learning, still introducing, just doing some spaced repetition, and we'll keep hammering away at it until it sinks in. Enemy cotton. That's a great emote for for that for for piece of shoots comment there. On point indeed. Awesome, Fat Cat. I'm glad you enjoyed it. Got a lot of new followers today. It's awesome. I feel like we got a lot of new people that haven't been here before. Maybe it was because I put the React tag on my stream today. Thank you for the follows, everybody. And I think was it oh yeah, and Grats. Thank you again for the 5 subs. Much appreciated. Thank you so much. React is the ultimate buzzword. Yeah, all the better for us to learn it, so we can have that buzzword on our resumes, right? Okay. I'm not seeing any other questions right now. I'm going to go ahead and pull up the raid screen here. But feel free to ask if anybody thinks of anything else they'd like to ask. It usually takes me a minute to pull this up. Hey, Darth. Never fear, Darth. We are going to be doing more React. If you want to join me again this coming Wednesday, we're going to keep working on React. We're going to keep going through it. And yeah, we're going to be spending a lot of time on this I'm sure, in the coming weeks. Thanks. Thank you, piece of shoot. All right. Let's do a raid. And we got several choices today. I would say, so I'm seeing, if anybody has any suggestions for raids, feel free to say so. I'm looking for somebody who's actually doing some dev work. We got several of our friends that are playing games right now, which is fine. But I normally like to try to raid somebody who's actually doing some dev work. We've got our friend CM Griffin, as always, a fun raid. They look like they're doing game dev today. But let me know if anybody else has a suggestion. I think Eduardo RFS is a great choice too, but I do believe they only stream in Spanish on the weekends. Or is it Spanish or Portuguese? I apologize. But yes, they do not stream in English on the weekends. So it's looking like CM Griffin. All right, seeing no objections, we'll go ahead and raid them. They're always fun. They are definitely doing some dev work today. All right. I will see you all again on Wednesday. Well, I'll see you all on Tuesday first. We'll do some more reacting class. Um, we'll do some more reacting class. And then on Wednesday, we'll do more React on my stream. So, all right. Everybody have a great rest of your day. And I will see you all on Tuesday and then on Wednesday and more React. Have a great evening. Talk to you soon. Bye bye. And raid is queuing up and go.